Okay, so we are solving question 5. We solved question 1, 2, 3, 4, and 8. So we are solving question 5 and 6 right now. So Dan, start reading for us.
Okay, sir. A. Determine the missing probability key. B. Identify the most likely repair cost and state its probability. C. Calculate the probability that the repair cost is I, at least 3,000 Ghana cedis. II, not more than 1,000 Ghana cedis. And III, between 1,000 Ghana cedis and 6,000 Ghana cedis inclusive. D. The provider considers the portfolio manageable if there is at least a 60% probability that a repair costs no more than 3,000 Ghana cedis. Determine whether this criterion is met. And E. Explain what the probability of a zero repair cost may represent in the context of a warranty claim.
All right, so that's it. So when you finish reading the requirements, you know that the question is for probability. Then you start from the top. Now let's read the top.
A warranty provider classifies the repair cost on a randomly selected claim as follows. The repair cost X 0136 with Ghana City 000. Then the probability P of X 0.2, 0.20, K 0.35, and 0.15.
Okay, so we are done. Let's start. It's not difficult. It's not difficult. So first, A said determine the missing probability. K. So question 5. Let's start with A. The missing probability. The missing probability. So watch. Always the total probability should be 1. The total. Total. Yeah. Total probability should always be 1. So if they said we have 0.2, K, 0.3, and 0.15, and the total probability should be 1, is it not very easy to determine what K is? Guys, do you follow?
Yes.
So what will be the missing probability? So how do you find the missing probability? Those who are not in the study group, join the link in the WhatsApp group and you join it. So how do you find the missing probability? If the total probability should be 1 and K has no value, how do you find the K?
You add the rest and subtract from
You add
1.
the rest and
That's
subtract
it.
from 1.
That's it. So determine the missing probability K. That's it. So we say probability will be equal to, or probability, right? Let me put a column here. Is such that, then I'll add 0.2 plus K plus this equals 1. So 0.2, 0.35, 0.15, 0.2, 0.35, 0.15, all equals what? 1. Then I'll make K the subject, or let me group like terms. So K will be plus 0.2. Then 0.35 and 0.15 will give me what? 0.6, right? 0.5 equals 1. Is that correct?
Yes.
Good. Then I'll have K plus what? 0.7 equals 1. So K will be equal to 1 minus 0.7. K will be equal to what? 0.3. Is it difficult?
No.
We are done. That's A. So we are done with this. Identify the most likely repair cost and state its probability. So what do you think is the most likely repair cost? So watch this repair costs. The repair cost is like the frequency. Is that the most likely repair costs? Most likely, okay. So here it's 0,000. It's in thousands. So this is 1,000. This is 3,000. This is 6,000. So if you want to find okay, let's say the repair costs are X values. Let's leave it out as a frequency. The way it says, identify the most likely in probability, it starts from -1 to 1. That's probability for you. Starts from -1 to 1. Okay. So -1 means it is highly likely, or 1 means that it will definitely happen, right? 0.5, if I say 0.5, it means that it is relative. It may happen, it may not happen. Are you getting it? Are you getting it? Hello, are we
Yes.
following?
Yes.
So 1 means it will definitely, let me put it in simple terms, it will definitely happen because the probability is 1. It's sure. It is a sure banker. It is certain that it's going to manifest. 1. 0.5 means that it is, let's say, highly probable, or it may happen, it may not happen. 0.5. Okay. So looking at, this says, identify the most likely. Another word I can use in place of probability is likelihood. Likelihood. So probability is a noun. Another word I can use in place of it is like the likelihood. The probability that somebody will come to school. The likelihood that somebody will come to school. Then I can say it is probable that. Then I can also say that it is likely that. So when it says identify the most likely, in other words, identify the most probable. And when you say probability, you have to think about -1 to 1. So in this question under consideration, the probability values are from 0.2, K is 0.3, and it ends at 0.15. We don't have -1, we don't have 0.5. These are the probability values. And the question is saying that based on these probability values, which one shows that a repair cost is most likely, or identify the most likely repair cost and state its probability. So what do you think?
So
which of the cost is most likely, and what is the probability?
So please, I think that the most likely repair cost is 3,000 Ghana cedis, and its probability is 5.
Is 0.3. You all get it? Why? Because amongst all the probability, the highest is 0.35. So it means that 0 is 0.2. It is a low probability. 1 is 0.3. 3 is 0.9. 6 is 0.15. So amongst all, the one which is likely to occur, right, is 3,000 because its probability is very high. Are you getting it? So it says identify the most likely repair cost. So just look at the probability, and the probability will tell you the most likely repair cost. The cost is here. So here, the highest probability, which is the most likely, is 0.35. It's not 5 because you don't have 0.5 here. So 0.35. And what is its, the highest probability, or the most likely probability, is 0.35. And what is the corresponding repair cost? It is 3. 3, there are thousands here. So you add the 3 zeros to the 3, which will give us what? 3,000. Are you good? Are you good?
Yes.
So I'm going to now answer the D. Identify the most likely repair cost. So the most likely repair cost is 3,000 Ghana cedis. And its probability is what? 0.35. Let me write it. So B. The most likely repair cost is what? 3,000 Ghana cedis. And its probability is what? 0.35. You don't work, you don't study. Study is not easy. So you can be asking, so how am I able to teach all these students different accounting and finance, admin, masters, this prophet? How am I able to teach all the? It's not easy to study. So don't think you are level 100. You are very low down the ladder. I getting it. So that's why you have to see yourself so that you sit down and study. You sit down and study. Don't, even if you know anything, you don't know anything, you have to sit down and study. So like this is undergrad, right? So undergrad, we have level 1. This is level 4. That's the highest. We have level 3. We have level 2. We have level 1. So you are here. Look at where you are. From here, you have to go to, let's say, masters. From masters, maybe you can go to professional. Like masters takes 2 years. Masters, we have, let's say, level 1. We have year 1, year 2. Then let's say professional. Are you getting it? So you are here. Look at where you are. Look at where level 1, level 100. You are now going to go to level 200, 300, 400. Then maybe if you want to do your masters, you can do 2 years, or you go and do professional. And I can teach everyone all those on this slide. I can teach from the professional down to level 100. So I'm teaching you here. Are you getting it? So it means that you have to sit down and study. So if people are doing masters or professional, if they don't get it, I fire them. Then what about you who are just down the ladder, level 100? I'll kill you. I'll kill you for your time. If people are masters or professional, they misbehave, I fire them. Then how much more you are level 100? So make sure you sit down and study. That's my advice. I can't force you to study, but I can help you to understand, and I'll teach you approaches. I can't come and write a paper for you. Don't joke with education. You have no idea. Okay, guys. Yeah, let's go on. Here and here. We are done. Let's move on. C. Someone should read C for us. You have to score A. It's very easy to score A because they've told you, they give you the questions which will feature in the exam. You don't know which one will come to yours, but they said, go and practice these questions. The question will be taken from this area. They've told you. They've told you. So you cannot afford to score risk. And I didn't understand. Share the channel with your friends so that they also watch. So that you can all pass together. You share it with them. That's how I'm recording it. You have to pass and score A because they will bring the same questions. They will be lifting the questions. They can change the figures. They'll bring the same question. They will change the figures. So you can't afford to have a reset. And you don't need somebody to explain it to you again because I've already explained it. I've explained it. Right? You don't need somebody to explain it to you. I've explained it I'm teaching the techniques, everything. Why do you think people want me to teach them? So don't joke when I'm teaching. I want you to pass and pass well. And you are down the ladder level 100. So just make sure you study. Okay, so let's see. C. Someone should read C for us.
Calculate the probability that
Hold on. Let me speak to someone. Guys, what do you think I should tell the boss? Tell me something to tell the man.
because it is agreement between both of you, so you don't have to agree with him.
What kind of attitude is this? Some men, Okay, I'm coming. Okay, let's continue. All right, so let's read the C. Let me check what I'm recording it. I've done the work for him. He's now saying he's complaining about 1,000 cedis. When he calls me, I'll tell him my mind. Okay, guys, let's continue. Read it for me. The C.
Calculate the probability that the repair cost is I, at least 3,000 Ghana cedis. I, not more than 1,000 Ghana cedis. And I, between 1,000 Ghana cedis and 6,000 Ghana cedis inclusive.
If you were here and you followed us when we did the work, hold on for me. Who said I should give it to God? Who said that? Okay, guys, let's continue. I'm back. Let's continue. somebody, I'm charging the person. He says you pay. I should give it to God. If you don't keep quiet, what I'll come and do to you? You never like me. All right, guys, let's continue.
Calculate the probability.
Yeah, read it. Let's get it done. Okay, you read it.
Calculate the
It's all right. You read it. Calculate the probability that the repair costs. Good. Now watch. He says you find the probability. So it means that I here, the question says you find the probability of the I. Probability of the II. Probability of the III. So like I said, if you joined us yesterday, this question is similar. There is some portion in the question 4, which has probability. So watch. I can say, now, before I start with the C, okay, before I start with the C, here, C. The first thing I'll write is, I'll say the I, okay, the I. What is the I? Probability that it is at least 3,000. And yesterday, I explained what at least meant. And I explained what at most meant. And I explained what a few meant, fewer than, lower than. We will do that again today. So here I have to first write what is called probability notation. The notation is something like this. When we say at least 3,000, it's simply saying that all the figures you are going to list, the lowest or the least or the minimum should be 3,000. It means that after 3,000, the figure should be bigger than 3,000. So I can have 3,000, 4,000, 5,000, 6,000. They are all bigger than 3,000. So the least should be 3,000 in the figures. Do you get it? Do we get it?
Yes.
So another name I can give to replace the phrase at least is to say it is the minimum. So I can say minimum of 3,000, and it's the same as at least. So in inequalities, we use the symbol, or we use the inequality symbol, this. This is called 3,000. This how we write it in inequality. Then all the figures which will be 3,000 or more, we'll use X to represent it. So the figures like 4,000, 5,000, all the figures which are more than 3,000, we use X to represent those figures. Do you understand it?
Yes.
Good. So if I want to write the notation, probability, we use P to represent probability. So I can say that probability of X is greater than or equal to 3,000. Or I can say probability into brackets at least 3,000. Do you get it?
No.
This at least 3,000, which is in the question. This at least 3,000. I can just put probability here. I can just say P into brackets. That's the probability. That's the notation.
Yes.
So I can write this as the notation, or I can write the one with the X as the notation. Are you getting it?
Okay. Yes.
So CI. The question is that you find the probability that it is at least 3,000. So I will say P into brackets at least. I'll just put at least 3,000 in the brackets. 3,000 Ghana cedis. You must first write a notation before you can start to solve it. Or you can say P X is greater than or more than greater than or equal to what? 3,000.
3,000.
Whichever one you write, you are okay to go. Are you okay?
Yes.
Hold on. My student is calling me. Okay, guys, let's continue. So when I saw the probability, first write the notation. And the notation is what I've written. P into bracket at least 3,000. Just copy the same figure, the I, and just put it in a bracket and write P behind it. That is it. Or if you want to write it mathematically, that's the other way you can write it. At least means greater than or equal to. At least means that the figure should be 3,000 and above. That's what it means. It means all the figures you write, the lowest or the least or the smallest figure should be 3,000. The opposite is called at most. So if I say at most 5,000, it means that at most 5,000, it means that all the figures are on list. The highest of all of them should be 5,000. And that one, we use the inequality less than or equal to. If I say at most 5,000, it means of all the figures are on list, the highest should be 5,000. And that one comes to the II. You see, it says not more than 1,000. It's the same as at most. And also it's also the same as maximum. Guys, do we get it?
Yes.
So the II, not more than 1,000. If I want to write a notation, I'll just put the not more than 1,000 in a bracket and put P behind it. So let me also open a space and write it. So let's say II. Right? P into brackets, not more than 1,000. Or P into bracket X, right? Then I will say less than or equal to 1,000. Well, it says the figures you are going to list, the amount you are going to write, it shouldn't be more than 1,000. It means the highest should be 1,000. In other words, it's also called at most. At most. You want to get to level 3, 200 second semester, you do a course which is called linear programming. Linear programming, you're using this in inequalities again. That is why always I advise that whatever you learn in level 100, make sure you don't forget it. Make sure you don't forget, because you're going to use it again. Statistics, you're going to use statistics again. Regression, you're going to use it again. This inequality, more than, less than, you're going to use them again. So make sure you don't forget it. Probability, you're going to meet this again, but in different ways. Economics, you are going to meet this again. It is called managerial economics. It's very difficult. Level 300. You also meet the same level 100 economics. You also meet a higher version in level 200 second semester. So whatever you are learning, don't just feel I'm learning, I'm throwing it away. You're going to meet the higher version of it. So in the event, even the level 100, you were struggling, how more can you work with the difficult ones, which is ahead of you? Hence, I always tell you, it is easier to score A's in level 100 because the courses are not difficult. Some of them, they are high school. The economics are like high school economics. But when you are progressing, level 200, you do higher economics. Level 300, difficult economics. And when you go to masters 2, there's another difficult economics there. So make sure your grounds are very solid from level 100. Get the A's so that when you are climbing up and the course become difficult, and you are even scoring B and B minus, you'll be safe. That's my advice. All right. So calculate the probability that the repair cost is. So as I've said, you can just write the notation by saying P into bracket at least 3,000. Just repeat the same thing and put into bracket P. Then the next one to not more than 1,000 into bracket P. The next one. The last one, you can say, well, when you get to the last one, somebody will tell me what to do and I'll write it. Okay. So let's start. Let's deal with at least 3,000. So we go to the data set. This is the table. And we look at the figure. The figure. It says at least 3,000. So where is 3,000? Here. Is that correct? Is that correct?
Yes.
What is the K? What is the K probability? The K was what? 0.3. Do you get it?
0.3.
Good.
Yes.
Let me write it here. So when they said I should find the probability, calculate the probability, they didn't ask me to calculate for the cost. They said probability. So if it is at least 3,000, what do you think the probability value should be? Okay.
0.0.
Which probabilities are below 3,000?
K and then that's 0.3 and then 0.2.
0.15.
Oh, sorry.
Come again.
0.15.
Good. So the way I have to go with it is this. Watch. So we have probability of 0. Is that correct?
Yes.
Then we have probability of what?
0.3.
We have, let me write it this way. Probability of what? X is equal to 0. Is that correct?
Yes.
So when X is 0, it is 0.2. Then we have probability of what? X is equal to 1. Which is what? So when X is 1, what is the probability? 0.3.
0.3.
Are we good?
Yes.
Uh-huh. So they are saying that at least, no, hold on. I'm making a mistake. Let me look at the sign. At least means it's more than 3,000. Have you seen it?
Yes.
Yes.
If it's more than 3,000, of all the figures we have in the table, which figure is more than 3,000 Ghana cedis?
6,000.
6,000. It's 6,000. So it is here, this one. So by looking at the sign, it is at least 3,000. It means it is greater than or equal to 3,000. So we have to include the 3,000. Are you getting it?
Yes.
Good. Because if I say list numbers greater than or equal to 4, where would you start the figures from? X is greater than or equal to 4. Where do you start the figures from?
I'll
4.
start from
You start from where?
4.
4. Good. Then you go to where? 5. So if it's saying that at least 3,000, where would you start the figures from?
3,000.
3,000 and what?
3,000.
And what's the next
6,000.
one? 6,000. Good.
6,000.
That's it. So let's go. P into brackets. X is greater than or equal to what? 3,000. Equals, pay attention. Oh. So what are the probabilities above 3,000? You can say that this probability into brackets, when X is 3, what is the probability? When X is 3, what is the probability?
0.35.
0. Do you understand what I'm writing?
Yes.
Yes.
When you write it this way, it shows you understand it. That's why I'm using the notation. This is called notation. When probability is, when X is 6, when this X, when it is 6, that's what I'm writing here. When X is 6, what is the probability?
0.15.
We will say 0.15. Okay. So if I say probability into bracket X is greater than or equal to 3,000, it means that it consists of probability into brackets X equals 3,000 and plus probability into bracket X equals what? 6,000. Do you get it?
Yes.
Guys, do you get it?
Yes, sir.
So this is equals, what is the probability that X is 3,000? 0.35. What is the probability that X is 0.1? What is the probability that X is 6,000? It is 0.15.
0.15.
So plus 0.15. So together, what do we have? 0.5. Are you good?
Yes.
Yes.
That's why you have to understand the notation. That's why these symbols. You have to understand these symbols. This. Well, if they say at least 3,000 and you don't understand it very well, then you can fall on the notation on the right. Are you getting it? And the notation on the right, if I'm listing numbers, if I'm listing figures, X is greater than 3,000. What figures are greater than or equal to 3,000? Those are the X. It will start with what? 3X is 3,000, X is 6,000, and X is any other figure. But from our table, after the 3, the next figure is what? 6. So that's all that we use. Guys, are you okay?
Yes.
Good. So what I'm writing here, this P into bracket, this is called notation. It makes your work easier. It tells the examiner that you understand the notation. It tells the examiner that you understand it. So X values, the X is greater than or equal to 3,000 means the X values which are more than 3,000, which are more than or equal to 3,000. So it will start with 3,000. So that's equals, then to go to X equals 6,000. Are you getting it? So when I add them, the probability is what? 0.5. Are you good?
Yes.
Yes.
Now let's look at II. II says probability that not more than the repair cost is not more than 1,000. It's not more than 1,000. So let's look at the data sets, the table. Which figures are not more than 1,000? Okay, look, it said it's not more than. If they say it's not more than, you may be confused. But then if I write it mathematically by using the notation P into brackets, a certain figure, let that figure be X, or let those figures be X, they are not more than 1,000 means that they cannot exceed 1,000. So we use the notation less than or equal to, which is the opposite side of the at least. This is at least. So the opposite side is less than or equal to. Are you getting it?
Yes.
It means the x values I'm going to list, no matter what the x values are, they should reach 1,000 exactly. They should not be more than it. Are you good?
Yes.
So if you write it this way, if you're able to learn to write it this way,
Yes.
you understand it better. That's why I wrote it this way. X is less than or equal to 1,000, meaning that the x values, they could be 500 x values, but all the 500 x values, they can never exceed 1,000. The maximum, the highest, will be 1,000. So this less than or equal to, sometimes we call it at most. Sometimes we call it not more than. Sometimes we call it maximum. So don't forget. At most means of all the numbers, the highest, the most highest number. That is why we use this sign. And when we use the greater than or equal to, we call it at least or minimum or fewer than. No, at least or the minimum. Are you getting it? That's when we use the at least. That's when we use the greater than or equal to. So if you understand that it's the probability into bracket x is less than or equal to 1,000, which figures here falls within the notation p into bracket x is less than or equal to 1,000. Which figures? Tell me. Yes.
0,000.
Come again.
It's the 0 and then the 1.
0,000.
Good.
The
It's the
0
0 and the
and then
1.
the 1.
Very good. Very good. So it's a 0 because 0 is a figure which falls below. On the table, we have 0, 1, 2, 3. So if you include 3,000, 3,000 is more than 1,000. The person is saying that it shouldn't be more than 1,000. So it means 1,000 is inclusive. And 0, those are the only two. So it's 0 and 1,000. So I will say P, that's how I'm going to write it. So I'll say P, probability of x less than or equal to 1,000 equals, then I'll write here P into brackets x equals 0. I want you to understand it. That's why I'm taking my time. So P into brackets x equals 0. Then P into brackets x equals 1. That's what I'm going to write. So let me write here. P into brackets x equals 0. Then P into brackets x equals 1. So what is the probability that x equals 0? What is the probability that x equals 0? The probability is what? 0.2. Plus, what is the probability that x is 1? It is what? 0.3, which we saw. So you know what will be the probability? 0.5. Do we get it?
Yes.
That's what I'm going to do here. So that's why I like writing it this way, better than that way. Because if you don't get it this way, if you don't understand it by using the inequality less than or equal to and greater than or equal to, and you go and write it this way, you may get stuck. So we'll say that probability into bracket x is less than or equal to 1,000 is made up of the probability that x is equal to 0 plus the probability that x is equal to what? 1. And the probability that x equals 0 is 0.2. And the probability that x equals to 1 is what? 0.3. Together gives us what? 0.5.
0.5.
Guys, are we good?
Yes.
Yes.
Dan, your question.
Okay, so my question is, seeing the probability that x is equal to 0, does it also mean the 0 Ghana cedis, like 0,000 cedis, and then the 1,000 cedis? Because the earlier one you added that is 3,000, but here you were doing it single.
Okay, yeah, thanks. You can write it that way. Now, okay, yeah. So you want to write 0,000, right?
Yes, sir.
Dan, where did you go to high school?
At the Federal College.
Hey, babe. And you want to write, Bema, you guys should listen. I think you don't understand what the gentleman is saying. He said, I wrote 3,000. I brought 1,000. The 6 is 6,000. I brought 1,000. Though it is just written 6 here, 3 here. So if it is 0 here, If it is 0 here, I have to also write 0,000.
Uh,
Have you seen the kind of people we have in the class? Okay, so then you can write your 0,000 or you can write 0, okay? That's fine. Then you have here x equals what? 1,000. That's fine.
1,000.
0,000. Simple. Okay, that's fine. That's fine. All right, let's go. So we are done. That's it here. Now let's go to this part. We are on III here. It says, calculate the probability that the repair cost is between. So again, you can just put a bracket here. You can put a bracket here. Then you put your P there as your III probability. Or you would say, look at the way I'm writing it. Between. When it's between, just write probability into brackets. Right? Between what figures? What's the first figure?
1,000.
1,000.
So you write 1,000 here. Hey, I'll head your lips. So you write 1,000 here.
Hey, man, quit taking your phone and alone.
So you write the lowest between 1,000, that 1,000 here. Leave a space. What is the next figure?
6,000. 6,000.
Then write 6,000 here. Watch. Then in between them, in the middle, write X. Then you write less than, less than. Why did I introduce the equal sign? Here it says 6,000 inclusive. Inclusive means that both of them, the 1,000 and 6,000 are apart. Are you getting it?
Yes.
Okay.
You know, it said if there were no inclusive, I would have I would have brought in the equals against the inequality of the less than. So as if the question said between 1,000 and 6,000 without inclusive, this is how it will be. Right? But here it says 1,000 and 6,000 inclusive. Inclusive means 6,000 and 1,000 are part of the deal. Are you getting it?
Yes.
So here, from the table here, watch. I can write it this way. I can say P into bracket 1. There's a 1,000 and 6,000, 6. Then I'll put the X in between. Then I'll make it less than or equal to, less than or equal to. That's between. That's how I write it between. Do you get it?
Yes.
Okay, so that's what I'm going to write. So you can say I. Probability that between 1,000. Are you writing exams? Your friend is saying on Friday. Okay, let's continue. Then I'll say that equals, right? Probability. Can you see my screen?
Yes.
Can you see my screen?
Yes.
No.
So
Yes.
probability that 1,000, leave a space, write 6,000 on the other hand, put an X between. Because it is inclusive, I'll make it less than or equal to. This, what I've just written, the notation I've just written, this is how we read it. Probability that, right, X is greater than or equal to 1,000, but less than or equal to what? 6,000. Are you getting it? Probability that X is greater than or equal to 1,000. So I'm reading it this way. Probability that X, so if I'm reading it from the left, 1,000 to the X, I'm reading from the left to the right. Let's say from 1,000 to X, I will say 1,000 is less than or equal to X. But if I'm reading from the X to the left, I will say X is greater than or equal to 1,000. Do we get it? Do we get it?
Yeah. Yeah. Yes, sir.
If I'm reading it
Yes,
from
sir.
1,000 to 1,000 to X, I'll say 1,000 is less than or equal to X. But if I'm reading it from the X to 1,000, I will say X is greater than or equal to 1,000. Right?
Yes.
Then if I'm reading from the X to 6,000, I'll say X is less than or equal to 6,000. But if I'm reading from the 6,000 to the X, I will say 6,000 is greater than or equal to what? X.
X.
So in other words, the X value, it should be more, it should start from 1,000, and it should end at 6,000. That's what it means. Because of the less than or equal to, it means you start from 1,000 and end at 6,000. However, if it were P into bracket 1, let's say 1,000X, if it were like this, here you could see that it is X is less than or equal, X is less than 1,000. X is greater than 1,000, but less than 6,000. In this case, the X value could start from, let's say, 2,000 and end at, say, 5,000. That would be the X values. Do we get it?
Yes.
We are not going to include the 1,000 and 6,000. Why? Because the inequalities of less than are not less than or equal to like the one we are solving right now. Are you good?
Yes.
Is it only one person who understands it?
We understand.
Okay, that's fine. Let's go. So between 1,000 and 6,000, that is the notation. Then I'll make it equals, right? Now, all the members within the range of 1,000 to 6,000, they'll be taken care of. So here, for example, I'll have P into bracket X equals 1. Because it's parts. When I'm listing the values, X equals 1. Then P into bracket X equals 3. Then P into bracket what? X equals 6. So I'll add this to this. I'll add this to this. Then I'll write the annotations. This will be this is the full expression of this. So I'll write it this way. Probability that X equals 1,000 plus probability that X equals what? 3,000 plus probability that X equals what? 6,000. So what's the probability that X equals 1,000? It is 0.3, 0.35, 0.15. So X equals 3 is 0.3. X equals 1,000 is 0.35. X equals 6,000, the probability is what? 0.15. So in all, what do we have?
0.8.
0.8, that's it. Are we good? You are done.
Yeah.
Yes.
Enyedi. Tiase. Intina ma furniture ma bra me che wa pesa on tiase. O tiase I do exams. Just go and practice. Don't say, oh, he has taught and I've understood, so you can do it in exam. Hey, go and sit down and practice. So the lazy work, go and sit down and practice. I'll show you something on the Chartered Accountants page. My main fan Shem. Some of you, movie say Chartered Accountant, we will a masters or both degree or Chartered Accountant or try no failing. So let me show you something. Go and sit down, find time, sit down and practice. Don't go and joke. So watch. Look at this. Study group, right? CR. ICAG. Instead of Chartered Accountants. So watch. 117 members. I'm the one who opened the group. This is my WhatsApp group. One of my study groups. Look at what I wrote. I sent to them. If I sent it on is it this Monday? Yeah, this Monday. I said, if you are unable to solve on your own the past questions your lecturer has solved with you during the lectures, then it can be concluded that when similar questions feature in the final exams, you won't be able to solve them. So like the tutorial questions we are solving, if you cannot solve them on your own, the way I'm explaining it, you cannot sit down and solve them on your own. When they bring the same questions in the exams, you cannot solve them. Guys, you understand it?
Yes.
Yes, because if you cannot solve what I'm solving with you on your own, the way I'm using the approach, if you don't go and sit down and practice it, and you cannot solve it on your own, and you think you've understood, when you go to the exam and they bring the same question, you cannot solve it. Those who can solve it are those who go and solve the same question, and they'll be able to solve it the way I solved it, or get the answer I got, following the steps I used. Because the steps I used is a formal step, or they are the formal steps used in calculating probability. If you're able to do that, you pass. So these are chartered accountants. These are chartered accountants, and I'm even telling you the same, that if you're unable to solve on your own, the past questions, like here, the trial questions, your lecturer, which I am solving, has solved with you during the lectures, then it can be concluded that when similar questions feature in the final exam, you won't be able to solve them. Yes. Thus, you'll be bound to fail. I get it. So I show them 4 stages, 4-stage practice strategy. What I ask them to do, 4 stages. Right? And me, I like write, so I can write plenty grammar for them. I get it. And look at those who read. All of them will read. If you not read, sleep. Look at them. Some of them, they have like 4 MBAs. Mr. Paul. 4 MBAs. So many of them. They all read. If you not read, stay there. I'm not going to write the exam. They will read it and go and practice. I send the same thing here. All the groups, I send the same thing. And 2 people liked it. I get it. I send the same thing to the group. So what I'm teaching you, don't think we are joking here. It's your destiny. I've told you, level 100. Those of you who are not in the study groups, join, so that when you are sending notices, you will have time. So that's it here. Okay, so we are done. What did I want to explain? So go and practice. Go and sit down, watch the video again and practice. If you are writing, make sure you pick the same question, solve it on your own. Because level 100 and 200, you should score your A. Once you get to level 300, the course becomes very, very difficult. I told those who I met yesterday that the level 300s, those who are now going to level 300 first semester, if you're an accounting student, accounting and finance, you do 4 calculation courses a semester in that semester. 4 calculation. Oh, yeah, 4 now SIA theories account 4 calculation courses. So we are done. So make sure you pass. Okay, let's go. D. The provider considers the portfolio manageable if there is at least 60%. Okay, if there is what? At least 60% probability that a repair costs no more than 3,000. Determine whether this criterion is met. So the provider considers the portfolio manageable if there is at least 60% probability that a repair costs no more than what? 3,000. At least 60%. When a repair costs no more than determine whether the criteria is met. Okay. So how do you think we should approach this? You see, it's using the same words we used again. Pay attention. At least. No more than. No more than means what?
At most.
It shouldn't be more than the 3,000.
Good. So what will be the notation? Probability into bracket what?
X
Good.
is equal to
It's less than
good. It's
Greater
less
than
than or equal to.
less
or equal to
Or can't
3,000.
chorus for no. Chorus for no. Omo ntuni mo kwa ni mo. Edu chorus pe. No mo na akeni. Okay, that's correct. So it is not no more than. We are still using the same. So is it that determine whether this, it says the provider considers the portfolio manageable if there is at least 60%, meaning if the portfolio, right? Please, Lisa. If you are able to score 60%, at least 60% means that you should do well to somewhere like 60%. It means if the cost, let's say if the cost is less at least or at most 60%, then it means that no. At least this is wrong. This should be at least. Are you getting it?
Yes.
Yes.
At least is greater than or equal to, right?
Equal to.
So it means
Yes.
if the portfolio is 60% or above, then the business considers the portfolio manager. If the probability is 60% or above, then the business considers manageable. So the provider considers the portfolio manageable if there is at least 60% probability that a repair costs no more than 3,000. So if the repair cost is less than 3,000, are you getting it? Then the business will consider the portfolio manageable. When you say portfolio is a combination of two or more things. So let's say someone has a Mercedes-Benz. He has a Benz, right? And the person has a Chrysler. And the person has Toyota Venza. So 3 vehicles. We will say, because there are more than one, we can say the person has a portfolio of vehicles or a pool of vehicles. Do you get it?
Yes.
So when you say that, the provider considers the portfolio manageable. The portfolio is combining 1, 2, or more of this is a portfolio. Are we good?
Yes.
Good. So it says the business considers the portfolio manageable if there is at least 60% probability that a repair costs no more than 3,000, meaning the X values here, the X probability we are going to work on, the X values we are going to work on, when we work on them, right, and we combine all the probabilities which are below the 3,000, if we combine them and they are 60% or more, it means those probabilities we combined, those costs we combined, they are what? Manageable. Are you good?
Yes.
So it says that if the probability that the repair cost, I'm taking it from here, the probability that the repair costs no more than 3,000. So we don't know which repair costs are less than or equal to 3,000, but I said that it should not be more than 3,000. So it should be less or equal to 3,000. So the X, if we find the X values and we add all their probabilities together, and their probabilities sum up to 60%, when their probabilities sum up to 0.6, oh, please. When the probability sum up to 60% or 0.6 and above, then that probability, okay, that probability will say those costs which were added together to give us the 0.6 or above, they are called a portfolio. Then we can say they are manageable. Why? Because when we got those costs and we added their probabilities together, we got either 60% or above or more. So they are manageable. Guys, we get it? Do we get it?
Yes.
Okay.
Yes, sir.
And if you understand it, you can do it yourself. If you understand it. So that's all. So first, let's go and find a probability that is no more than 3,000. Some of you you should start with your professional exam. If you are doing accounting, admin, you can start with your professional exams. So by the time you finish school, by the time you'll be out of school, you'll see that at least you are doing okay. Hey, this has appeared again. Okay, let's go. Ivy. Okay, putting that into get X is less than or equal to what? 3,000. Equals probability. So now let's come to the table. What values here, right, are less than or equal to 3,000? Which X values are less than or equal to 3,000?
0, 1, and 1.
1 and 3.
And
3.
Good. 0, 1, and
3,000.
3. 3 is inclusive because it is what? It's less than or equal to, so it's inclusive. So we'll say P into bracket what? X equals 0,000. Done. 0,000. Why? No actual. Why, Mr. Plus P into bracket X equals what? 1,000 plus P into bracket X equals what? 3,000. Are you good? So what is the probability that it is 0? What is the probability that X is 0? It is 0.2. So 0.2 here. What is the probability that it is 1? Don't forget that 1 is 1,000 there. 1 is 1,000. Here is 0. It was 0.3. It was 0.3.
0.3.
So 0.3. What is the probability that it is X is 3,000? 0.35.
0.35.
When we add, what do we have?
0.85.
Then, don't here this probability. But look at the question. The question changed it to what? Percentage. So we have to change this 0.85 to percentage, but multiply by what? 100%. Which will give us what? 85%.
85.
Now the 85%, we will now compare. So you see, we've combined 3 repair costs together. 0, 1,000, 3,000. They are the repair costs. That is why they are called portfolio. Because 1, 2, 3 is more than 2. It's 2 or more. So it's a combination. Therefore, it's a portfolio. And the question was saying that the provider considers the portfolio manageable if there's at least 60% probability that this. So we've finished. We are done with this side. We are done with this side. Now we are here. If now we got 85% for all the 3 portfolio put together. We'll compare the 85% to the benchmark. The benchmark is what? It should be 60% or more, right? So the 85% we got, which are the values which were less than or equal to 3,000 here, right? The 85%, is it more or 60% or less? We got 85%. Is it more, exactly 60% or less?
It's more.
More.
So if it is more, it says determine whether this criterion is met. So if it is more than it, is the portfolio manageable or it's not manageable?
It's
It's
manageable.
manageable.
Good. That's it. So it's like you're advising management. Determine whether this criterion is met. So you say that as the portfolio is 85%, as the portfolio is 85%, more than 60%, right? The portfolio is manageable. Are you good? Are you good?
Yes.
Please go and practice. I don't teach people to get research. Into kunya research who taught you? Say semano say you decrease. You decrease. Come on there. Why you the house semano and trail? Go and study. It's very easy. So V, E, we are on E. Question 6. E. Let's go and read what the E is. Explain what the probability of a 0 repair cost may represent in the context of warranty claim. Who knows warranty claim? Should I leave it for you to go and okay. So what it simply means is that there can be situations, okay? There can be situations. Here is a warranty. Provider classified the repair cost on randomly selected claim. It is like insurance claims. So there are some instances. It says you should explain what the probability of a 0 repair cost may represent in the context of a warranty claim. Warranty claim is filed by or is requested for by or it is demanded by the insured. let me go into insurance. Insurance, we have insured and insurer. Insurer is the insurance company. Then the insured is the person who goes to insure his or her property. Let's say if there's a warranty claim, right? He wants, let's say, let me put it this simple way, a compensation. So somebody who can file for a compensation to claim something, claim a compensation like a warranty, okay? Like a compensation or some amount of money. So it says, explain what the probability of a zero repair cost may represent a context of a warranty claim. Now, between the insured, which is the person, the individual who has applied for insurance, and the insurer who goes in for repair costs. Remember, repair costs, like the insurer is about a vehicle, right? So when the vehicle has an accident, then the insurance company will repair it. And these are the costs they incur when there's an insurance. I get it. Good. So my question is, so I've just answered the question. So let's move on. Well, explain what the probability of a zero repair cost may represent. Who bears the repair cost? It is the provider. It is the warranty provider who bears the repair costs, right? Now, so what does it mean for them to have a zero when the probability is 0.2? What it simply means is that let's try this, or when people 0.2 simply means that definitely people will file for claims. 0.2 of the total warranty recipients, right, will file for some claims. They want compensation. They want some compensation for damaged vehicle and others. But out of the entire 100% of the people, when 20% file their claim, right, it will not give the business grounds to spend any money. In other words, the claims they will file will be bogus. So the business will not spend any money. The will not spend any, despite some people file for a claim that, oh, let's say I've had an accident, so I'm going to tell the insurance company, so the insurance company will go and fix it for me. So if the insurance company goes to fix the vehicle, the clients, he spends money. Sometimes he spends 1,000. 30% of the people, when their claims, 5%, 15%, the business spends 6,000. But some 20% are there. When they file their claims and the business looks through, it will not spend any money, because sometimes it might be that they negligently caused the accident, or their claim was bogus, it was fictitious. So although some people will file some claims, the business will not spend any money. But 30% out of the 100%, which is the one in probability, 30% will file their claim. The business will spend 1,000, will spend a cost of 1,000. 35% will file their claim. The business will spend a cost of 3,000. 15% will file their claim. The business will spend a cost of 6,000. But there are some certain 20% when they file their claims and you inspect the documentation, you realize that it's bogus. So they don't even spend a peswa. Do you get it? Do you get it? Hello, do we get it?
Yes, sir.
Yes,
It could also be that sometimes like I'm saying, the purpose for which they are filing for the claim is not even covered by their insurance, or it's not covered by the warranty. Because when you go warranty claims, there are terms and conditions. So, like someone will go and have an accident, the accident is caused by himself. Then it comes to tell the business that the warranty provider that, oh, my vehicle has an accident for me. When the company goes through they inspect all the claim made by the person, the documentation, they realize that maybe they breached the warranty terms and conditions, or maybe what has caused them to experience damage to the vehicles, it was not part of the warranty terms and conditions. They will not pay any money. I get it.
Yes.
Or sometimes the cost for the damage of their vehicles was by their own doing. That's negligence. So if it's negligence, then the business cannot pay you for your negligence. Or some people deliberately destroy the vehicle and take them for warranty claim. So if the business expects that all these things have occurred, they will not even spend a peswa on repairing the cost. So the question says, explain what the probability of a zero repair cost may represent in the context of a warranty claim. So the zero repair costs The probability of a zero repair cost represent that 20% of the total clients, right, who may apply for a warranty claim, right, will not be entitled to, will not cause the business to spend any money on repair costs, right? Explain what the probability of a zero repair cost may represent in the context of a warranty claim. So the 20% or the 0.2 probability or the 20% of the clients, right? That's when I say 20%, I've changed the probability into percentage by multiplying by 100%. So 20%, which is here, this is 20%. 20% of the claims filed with the warranty provider, right, result in zero repair costs, right, due to reasons such as breach of warranty terms, due to reasons such as fictitious filing of the claim. That is what it means. So it doesn't mean that some people will not file claims. They will definitely file their claim. 20% of 100 will file the claims. But some, when they inspect it, when they inspect their documentation, whatever their reasons are, they realize that they breached the warranty terms and conditions. Some of the actions which led to the damage of their vehicles are not even captured in the terms, the warranty agreement. Some of their issues, they forged the figures. They are the cause of their own damage. If the business finds out all those, they will never pay any money. So it means that the business will incur zero cost. Are you good?
Yes.
Guys, are we all good?
Yes, sir.
Yes, sir.
Okay, so now let's put the grammar work. Explain what the probability of a zero repair cost may represent in the context of a warranty claim. So you could say that from the table, right? 20% of the warranty claims made on the business, right, can lead to a zero cost on repairs or can lead to zero repair costs. 20% of the warranty claims made on the service provider. Let me write the grammar. 20% when I don't write it on it for some time, that's how it becomes. 20% of the warranty claims. So you can say 20%, then you write into brackets 0.2 of the warranty claims made by the clients or made by clients, right, lead to zero repair costs by the service provider. In other words, 20% of the warranty claims made by the clients does not cause the business to spend any money. You can also write it this way. Does not cause the business to spend any money on repair costs. Or you can just write the way I'm writing it. 20% of the warranty claims made by clients lead to zero repair costs by the warranty provider. Or you can say that 20% of the warranty claims made by clients does not cause the business to spend any money on repair costs. Simply that way. Does not cause the business or does not cause the warranty provider to spend any money on repair costs. Does not cause the business to spend any money means zero repair costs. Then you give the reasons. This is because, or this can be due to breach of the warranty terms and conditions. Some of the reasons why the business may not spend the money when they see that some people have filed their warranty claims. Breach of the warranty terms and conditions, right? Warranty terms and conditions, falsifying of documents, falsifying or falsification of documents, or let's say falsification of claims, etc. That's it. We just finished it. Simple grammar. Last year, those who are now in level, who are now going to level 300, last year, they were also, around this time, they were also having their statistics, and I was teaching some of them. They were also coming to the class face to face. They were giving tutorial questions like this, and we were solving with them. Some people, they were joking. When we were solving, and I was telling them, they were going to bring the same question and change the figure. They were not even serious. They were not serious. And someone will be like, okay, I'm going to use ChatGPT. I was like, if you are going to use ChatGPT, no one is not saying don't go and use it. If you go and use it, do you understand what ChatGPT is telling you? They are just doing copy and paste. And several of them failed. I got to know some of them. The way I fired them in the group, I gave it to them. So the way I'm explaining it is simple and simplified for you to be able to write in your own words. Okay? Very simple, and you can be able to write in your own words. Done.
Say, please, the reason behind the warranty provider. Say, please, can you come again?
Explain
Where
what?
you-
Explain
where
what
you-
the probability. Okay, the reasons. Okay. This
Yes,
can be due to, you can say, this can be caused by, who is this? This can be due to breach of the warranty terms and conditions, falsification of claims, etc. If the business find out that they falsified claims, they will not pay any money to them. Falsification. So understand it once and for all. Go and write your exams and pass. Yeah, I'm advising you. If, for example, if those who completed, they want people to teach them statistics. I can call some of the guys, some of them, they are living around camp to go and teach them statistics. And they will charge. So when they say, when I come and teach me, why am I going to teach you statistics for? Then I'll call them, are you around? Say, yes, sir, I'm around. Say, how much will you take? Say, I'll take 500. I say, hey, 500. Say, yes. And I'll tell the person, I'll give you 400 to teach the person statistics for the exam. Say, oh, say, man, no, I'll take it. Then when I tell the person 400, you know what I'll go and tell the student who wants to do research? I'll tell the student should pay 1,000. And the student will be like, oh, Samano, it's expensive. Statistics, now, I say, how much will you pay? Samano, I'll pay 800. I say, oh, you pay 800. That's fine. Then these 800 cedis, I'll go and give my guy 400. And I'll use the 400 to buy data so that I can browse. Are you following? Are you following?
Yes, we are following.
Yeah, we are
I've
Yeah.
showed in the group those who are resetting statistics. They don't have this document too. Those who are resetting, they don't have this document. Don't even know what is going on. So, and you've seen there are about 9, and the other group is 2, so 11. And I want to come and teach them statistics. They should pay 50 cedis per. So if I want to teach them 2 days, they should pay 50 cedis. I'll call one guy. He's in the group. He's called Shadrach. He's going to level 300. He's in the group. I'll say, Shadrach, go and watch the videos and then go and teach the students. How much will you take? Now, if each person is paying 50 cedis, I'll tell Shadrach, take 20 cedis per person. So out of this 50, he's taking 20 cedis. But he will take 50 cedis from them because they will pay. They know it's research, they will pay. They want to graduate. So if they pay if they are 10, and each is paying the 50 cedis, Shadrach's own is 20 times 10. He will take 200. Or I can tell Shadrach to take 30 cedis because he's doing the teaching. So 300 will be his. Then you send the 200 to me on my Momo number. So if every day they are paying 50 cedis, which they will pay because it's a last minute exams, which they will pay, then every day Shadrach can get 300 cedis. So steady. They only. Okay, guys, we are done. We are done with it. So it says, explain what the probability of a zero repair cost may represent in the context of a warranty claim. And what it's saying is that 20%, the probability of 20% means 20% of the clients who file claims, right, do not cause the business to spend any money on their repairs. This could be due to the falsification of documents, the damages which were caused were negligence. You know, they were caused by the client themselves, or they have breached terms and conditions in the warranty agreement. So if they breach terms and conditions in the warranty agreement, the business, if they were incur any damage to their property or their vehicle, the business will not fix it for them. The business will not repair it for them. Guys, are we okay?
Yes,
Guys, are we
please.
okay? Who
Yes,
is Shuan
please.
there? Say races for
Yes.
now were
Yes,
doors.
please.
Races for now were doors. So assuming you are going forward, you get to level 200, and some people even say, "Oh, Semano, I'm right." I have so many of them. One quarter are writing receipts. I want you to teach me. And then they want you to leave my house and come and teach them. The price I'll give it to them. How can you pay me this money? Then I can even call one of you who is very good at. You see the questions you solved. Go and solve the same question with the students. Go and solve the same question. Just solve this. Pick them one and solve them as you have solved them. She will pay you this money. Sometimes 400, 500. So you just go and teach something you are going to teach the same person. Then the person will pay you. They don't come to me because they know the price I give them, they'll run away. So pray that some of them will venture. So when I'm going to realize I don't know what to do, then I'll contact one of you. I want somebody who's always consistent in class. Dan wasn't here last week. Shadrach, is he here?
Yes, I'm here.
Then I'll say, Shadrach, go and teach. Send me a message and what program are you reading?
Accounting and finance.
Send me a message, let me have your contact. So that when anyone comes, I'll say, go and teach the person. Then they'll pay you.
Okay, sir.
That's what I do. So that my guys, they always get money. Guys, we are done with question 5. We are done. Any question on question 5? Let's go on a break. 10 minutes time, let's come back. I would combine both or all of them and add them and upload them on the Zoom, on the channel, YouTube channel. But I'll write the topics which will be covered there. We've done, this is what? Probability. Good. And
Yes.
the next one we're going to do is called normal distribution. Question 6 is normal distribution. You are going to use this a lot. Next, you are going to use it a lot. So it might not all the questions might come in the form of normal distribution, but it's the concept. Okay, it's a concept of normal distribution. You use it in level 200 second semester. You use it in level 300 second semester. Normal distribution. When you go to masters, so you will learn about it. So just get ready for it. Normal distribution. That's question 6. Before that, so question 6. Let's talk about some characteristics of a normal distribution curve. It's a theory which they can ask you in exams. Characteristics of a normal distribution curve. I want to finish by 9 because I have some meetings. I want to fill them in. Where is Fina? She didn't join today. Yesterday she was here. And Portia.
We are even finishing, not yet.
Okay. Okay, so normal distribution. What are the characteristics of a normal distribution curve? So I'm writing X-text. X-text to represent characteristics of a normal distributional curve. So the normal distribution curve is always drawn this way. Okay. And we say that for the normal distribution curve, I'm looking at the diagram to write the characteristics. 1. So are you seeing how the diagram is? If I do it this way, what does it mean? Watch you. It's like this. When I add this to it, what does it look like? When I add this, the diagram on the left, when I add a tail at the top, right? What does it look like?
A bell.
Good. So we say it is bell-shaped, or it has a bell shape. It has a bell shape. 2. Now, when I have one, see, when you have like 100 Ghana cedi notes, and you fold the cedi notes into 2 equal halves, you fold it. So when I fold it, good, it becomes something like this. So this, I have folded the right side to fall on the left. So I have it like this. When I fold them and they fall, the right falls on the left, you will not see one longer than the other. You see them all exactly. It means the middle line is the line which divides both into 2 equal halves. That line which divides both into 2 equal halves is called symmetrical line. So there's the same thing with the normal distribution curve. The middle line is the vertical line. It divides or it splits the curve, the bell-shaped curve, into 2 equal halves. So we say that it is symmetrical in nature, meaning the left side is also the same as the right side. So it is symmetrical in nature. Three, the area. The area under the curve is 1. 1 is probability. So if I want to change the percentage, or 100%. Do we get it? Do we get it? Do we get it?
Yes.
When I say the area under the curve is 1, this is the area. It is 0.5 on the left. This is the area. It is 0.5 on the right. So when I add both 0.5 plus 0.5, what do we have? 1. Do we get it?
Yes.
You can even say it's asymptomatic, like the 2. So that the area under the curve is 1 or 100%. 4. The curve is continuous. The bell-shaped curve is what? Continuous. Or you can say it is smooth and continuous. You see that you don't see any breaks in the curve I drew. When I drew this, you don't see any dashes. You don't see it breaking like dashes like this. So we say it's a continuous data, right? It's continuous. 5. We said the curve doesn't touch the horizontal axis. This is the horizontal axis. The one I've deepened, the horizontal line. So the curve doesn't touch the horizontal axis, so it doesn't touch the x-axis. So the curve does not touch the horizontal axis or the x-axis. 6. We usually write here 3 m's. Under the vertical line, we write 3 m's. It means the mode, mean, and median are the same. Are you good? Are we good?
Yes.
Yes, sir.
So that is it. By looking at the curve alone, I've written all these. If you're able to understand it, you never forget it. Draw the curve. It looks like a bell, so it has a bell shape. The line here, symmetrical lines are lines which divide something into two equal halves, or we divide something evenly. So here it has a symmetrical line. Then the area under the curve, the left-hand side is 0.5, the right hand is 0.5. When we add them, they give us 1 probability or 100% percentages. The curve is smooth and continuous. I only wrote the curve is continuous. You can write the curve is smooth and continuous. You could see from the diagram that the curve never touches the x-axis or the horizontal axis. It never touches it. So the curve does not touch the horizontal axis. Then we usually write 3 m's in the middle, below the symmetrical line, the vertical line. So we say the mode, mean, and the 3 m's represent mode, mean, and median are the same. One of your questions, there was something like that in there. I think the question 1 or one of them. There was something on this normal distribution. Even yesterday, the question 4, I used normal distribution to explain something there. Are we okay? So if you are asked to state 2 or 4 characteristics of a normal distribution curve, if you're able to draw the curve, you will just examine it carefully and write what you see. Characteristics are like the features. Features are like, what do you see about the thing? Write what you can see about the thing. So what I can see is what I'm writing on, describing the curve. That's it here. Are we okay?
Sure, but please.
I'm listening.
Can I write it has 1 peak?
It has 1 what?
Peak.
1 what?
Peak. P-E-A-K.
It has 1 peak here.
Yeah, please.
Was it part? Okay. If it is part of the standard requirements, fine. I get it.
Okay.
Okay. If it's part of the standard requirements, fine. But mostly they not ask you to state more than 5. So at least you know any 5. It's 6, you should know any 5. That'll be fine. Let's go.
Thank
now
you.
let's solve the question. So question 6 is on normal distribution. Whenever I want to solve a normal distribution question, pay attention. We all know that we are going to first draw a normal distribution diagram. And then we'll convert it to what is called standard normal distribution diagram. So we are going to draw 2 diagrams. If you want to solve it standard or up to standard, you must first draw a normal distribution diagram and you convert it to a standard normal distribution diagram. The normal distribution diagram has X. So if I should draw the normal distribution diagram like this, right? All the values here, the middle here is the mean, right? Then the other sides of the mean are X values. But when we convert it to standard normal, in standard normal distribution, we don't use X. The X is also converted or transformed to become what is called a Z. So when I draw the curve like this, the mean will be here. The mean is usually 0 in the Z. Then on the other markings on the X-axis, we will say it is Z1 and what? Z2. Like X, X1, and X2. So if in the normal distribution we have X1, in the standard normal, we will have what is called Z1. If in the normal distribution we have X2, in the standard normal we have Z2. We are able to transform the X to become a Z by using what is called the Z-score. So the Z-score here converts the X to become Z. So that we use the X for normal distribution. We use the Z for standard normal distribution diagram. And the table we use the table for the Z, not the X. The table is for the Z. Are you good? Are you good?
Yes, sir.
This is it.
Yes.
Normal,
Yes, sir.
normal PDF. Areas under the standard normal curve. They didn't say normal curve, they said standard. What's standard because of what? It is a Z. So we can call this diagram here. So you could see here they were using X. Area under the normal curve. Normal curve is what? X. Normal curve is X. But standard normal is Z. Are you getting it? Standard normal is Z. Okay, standard normal is Z. This is it. This is it. Areas are not a standard normal curve. We use Z for it. Z, Z, Z. So this is it. Are you getting it? Z, standard normal curve. So that's what I'm trying to explain here. When it's a normal distribution, we use X. X. Then we use the Z-score to convert it or transform it from X to Z. The one is Z, we use the standard normal distribution diagram. So if it is X in the normal, when it goes to the Z, we'll find the Z of the X and write it in the standard normal. Are you good? Are we good?
Yes, sir.
Yo. So let's start solving the question. Somebody should read it for us. I think when we finish solving this, I'll end. I'm tired. It's question 6, right?
Yes.
When we finish, I'll rest. I'm tired. Then we'll be left with question 7. What is question 7 about? Let me see question 7. I think it's also normal distribution. It's also normal distribution. We've done question 8, so you should check the channel. Then we've not done question 9. Question 9 is on what? Oh, okay. Pearson's correlation coefficient. Okay. Correlation, regression and correlation. Okay. So we'll come and do this. Regression. Okay. So question 9 is on regression. Question 10 is on what? This one I should be able to solve it too. See. In fact, this one is similar to the question 4. This one is similar to question 4, which we solved yesterday. Frequency distribution is similar. You find a class midpoint, it's similar to it. So you're able to solve, if you follow how we solve the question 4, you're able to solve the question 10. So I don't think I may solve the question 10. Then the pharmacy here, this. So we'll go and solve the question 4. We solved it yesterday. It's in the group. If you're able to solve, understand the question 4 and solve it, a similar one is this. You follow the same approach for this. This is the X waiting time. This is the class intervals. You go and find this F. This is F. Then you construct the X, the class midpoint, right? Then you find the Fx, S squared and Fx squared. So you're able to solve the question 4. It is similar to question 4. You're able to solve the question 4, the same approach you use to solve this one. The calculator I used when the calculator technique I taught during the question 4, use the same for the question 10. Find the population variance and standard deviation, the same thing. So it means this question, this 4 and 10, one might go to regular, another can go to even, or one can go to the regular odd, the other one can go to the regular even, or one can go to the regular session, the other can go to the weekend and evening session. So you're able to solve question 4, you're able to solve question 10. So I'll not solve this one. It's the same as that. First, go and watch the video on question 4. So I use it to solve question 10. Then here, calculate the probability that a random selected customer waited. Question 4 too, there is probability in there. Then when you come here, the pharmacy aims for at least 70% of customers to wait less than 20 minutes. Today, we solved the question 5, right? The question 5 has something like this in it. So if you're able to understand how we solved the question 5, the last part, where he said, if it is 60% and it is not more than 3,000, how we're able to derive the probability? If you're able to follow through with that, this one should be okay for you to solve. Guys, are we okay?
Yes, sir.
Yes.
So go and solve question 4. It's the same approach. This is the class interval. This is the number of customers. Then you create another column for class midpoint. The way I chose the formulas or the formulae from the formula sheet, how I use the calculator to find the totals for all of them, find the mean. How do I use the calculator to find the population variance, and how I use the calculator to find the standard deviation. They are all in the question 4. The same question. Look at the question 4. I was in this question 4. Are you seeing it? number of workers, F, class intervals, right? X, F, X, Fx squared is the same as the question 10. Find the mean, find the population variance, population standard deviation. If one worker is selected at random, 40 workers, between this, are you getting it? The only difference is this E. The E, they didn't use the same thing. So the E here, I use normal distribution to explain something here. The E. So the only difference between this one and the first one are the major differences, or the major difference is the E. The E here, this is how they phrase the E. But in the question 10, the E, they changed it. You see the E, they changed the question 10. But it's the same, construct a table using this, the mean, population variance, standard deviation. This is like the question 4. This is like the question 4. The same probability, kind of. So if you understand that one, you can solve this. Then the E, they change the E. But this E, as I'm saying today, we solve question 5. Where is the question 5? This is question 5. You see the way this one was framed, this question. No, not that one. This one. It is probability, the way they frame this question, where we carry for the portfolio and got less than 60%, the way we did it, it is the same way you come and use for this E. You come and use it for the E here. If the pharmacy aims for at least is what? 70% or more. Greater than or equal to 70% of customers to wait less than 20 minutes. So if customers wait less than 20 minutes, we'll watch here. This is 20 minutes. These are the waiting time minutes. So this is 20 minutes, 20 minutes, 20 minutes, 20 minutes. So if they say less than 20 minutes, what intervals are less than 20 minutes? All these guys are less than 20 minutes. Do you understand it?
Yeah.
Do you understand it?
Yes.
Yes, sir.
So 15 to 19 is less than 20 minutes. So what is the number of customers? 15. 10 to 14 is less than 20 minutes. What is the number of customers? 18. 5 to 9 is less than 5 to 9 minutes is less than 20 minutes. What is the number of customers? 12. 0 to 4 is less than 20 minutes. What is the number of customers? 5. Then you add 5 to 12, which is 17. Add it to 18, which will give us around 35, right? Then come and add it to 15, right? Which is going to give us something like 50. So we divide this 50 by 60. That's the probability they want you to find here. So the pharmacy aims at least 70% of customers to wait less than 20 minutes. So we want to find the probability of what? X is less than what? 20 minutes. Then here, you go and find probability of what? X is equal to this interval. Probability of X is equal to this interval. Then you write it 15 plus probability of what? X is equal to this interval, which is what? 18 plus probability of X is equal to this interval plus probability of X is equal to what? 0.4. 0 is 0 to 4. So you add all the three, just as we did before. We did somewhere here, the way we're adding the probabilities here. Here, watch here. Here. So when you find the probability of X is less than 3 times, we're writing them one after the other. Then when you finish, we added their probabilities. We're writing the notation one after the other. When you finish, we added the probabilities. Then we got it here. Have you seen it? That's what I'm doing here. So when you write probability of X is less than 20, you write equals probability of X is equal to, let's say 15. Is it 15 to 19? Probability is X is equal to what? 15 to 19 interval plus probability of X is equal to what? 10 to 14 interval, 4. 10 to 14 interval plus probability equals what? 10 to 14. We're going to Guys, are you okay? Are we okay? Hello, are we okay?
Yes, please.
So if you write the notation, then you add them. Probability of x equals the interval plus probability of x equals in the interval. Probability of x equals 5 to 9 interval, right? Then plus. So that's all. So this one, it will be this one plus this one plus this one plus this. And the question says we find probability of x is less than or equal to what? 20, at least 20. So it will be equal to probability of this plus probability of this plus probability of that. When you write all of them, what if you should write the figures beneath them? 5 plus, where will we start from? So it'll start from 15. I don't know. You let me write it. So let me write so I can see what I mean. I don't want to solve it. It's the same thing. So that is the only portion. When if you go and do the normal distribution. So it says that find if it is 70%, the pharmacy aims for at least 70% of customers to wait less than 20 minutes. Determine whether the target was achieved. Here is the target. So what you just do is that you write the probability for this less than 20 minutes. So we'll say probability of x is less than what? It says customers to wait less than 20 minutes. So it's only less than, they didn't say at least. So less than 20 minutes. And which probabilities are less than 20? Which class intervals are less than 20 minutes? Is probability into bracket what? X is equal to, is it 15 to 19? Yeah, that's the next one. 15 to 19. So I'm going backwards, below 20. So 15 to 19 interval plus probability of what? 10 to 14. X is equal to 10 to 14 interval plus probability of, this is 9. So this should be 5 to 9. X is equal to 5 to 9 interval plus this is 5. So this should be probability of what? X equals 0 to 4. Have you seen it? I'm working on, I'm solving the E. Have you gotten it?
Yes, please.
Then I'll write the corresponding frequencies, number of customers, the corresponding frequencies, I'll write them. Okay. Or, yeah, I'll write the corresponding values here. The frequencies, I'll add all the frequencies. So, X, probability of X equals 15 to 19 is 15. Then I'll say 15. So, this one is 15. The first one here is 15. This is 15. Plus, probability of X equals 10 to 14 is what? 18. The next one is what? Probability of X,
12.
5 to 9 is 12. The last one is 5. So 12 plus 5. So all this is 12 plus what? 5.
5.
So when I add, what do I have? 50. 15 plus 5 is 20. Then 18 plus 12 is 30. So I'm going to have 50. Are you getting it? So this is the 50. Now, in fact, even these ones are not even probabilities, right? So when I finish, I can say 50 divided by what? 60. Are you getting it? Are you getting it? Hello, are you getting it? So 50 divided by 6, you have 0 point what? What do you have? 0 point what?
333.
Let's say 0.333. Let's say 0.33. That's it. Are you getting it? Now, because they're giving here as 70% in the question, I'll multiply this by what? 100%. What do we have? 33.3%. Are you good?
Yes.
Yes.
33.3%. So he's saying that determine whether the target was achieved and briefly advise management. Was the target achieved?
So the correct answer is 833. So the target will be achieved.
Is it 333 or 833?
833.
Hey, wait.
0.833.
Okay. 0.833. Thanks. So times 100%. What do we have? 83 point what? 3%. What? So was the target achieved?
Yes.
They said the target should be at least, and I've told you at least means the lowest should be 70%. So at least means all the figures, the lowest should be 70%. So it's 70% and above. That's it here. So if they go 83, was it more than the target? Yes. So can the target be achieved? Yes. So it said determine whether the target was achieved. So this is what you do. Right? If I want to state this 15, right? This 15 is frequency. So I could have also done it 15 over 60 plus 18 over 60 plus 12 over 60 plus 5 over 60. Then when I finish, when I add all, it's also give me the 0.83. I multiply by 100, it's to give me this. But when I do this 15 over 60, 18 over 60, it's to be a long issue. Are you getting it? It can be a long issue. So I'll just add them. When I finish, when I get the total, I'll come and divide it by 60. Then I'll just change percent and I'll compare with the 70%. That's it. Then you advise management whether the target was what? Achieved. That's it. So you could say the target was achieved and briefly advise management. Maybe the management should keep up with the policies they put in place to achieve the target, or they should improve it to exceed the target. They should improve it to continue exceeding the target, or they should put measures in place to ensure that they do not fall below their current level of 83%, nor below the 70% benchmark. Are you getting it? Are you getting it?
Yes,
please.
please.
Good. So it means today I finished solving question 10. Go and watch the question 4. The approach we learned there. You use it for the calculator techniques will give you all the values for A, B, C. The calculator technique will give you all the values. I explained it there in the question 4. So if you're able to solve the question 4, you can solve the A, B, C, D. But when it comes to the E, I'll solve the E with you. From A to D, go and watch question 4. If you solve the question 4, you can be able to solve this one. That's all. We use calculator, so that you learn how I use the calculator. Then you pick this question and practice it. Use the calculator. Be very confident with it. Then that is it. I'll solve the E for you. So I'm done with question 10. So today, I'll solve question 5. I'll solve question 10. Let's finish with question 6. Then we end our class. Then I know that I'm left with only question 7 and 9. We'll finish it tomorrow, God willing. Are we good?
Yes.
Oh dear. Kotwa 20. Why? Kotwa 20. Ebe market results ni we have 20. Ube soon. This easy thing, I don't have time. You see, when I'm teaching, I'll be receiving calls, WhatsApp messages on my other phone, but I still want to teach. So I want to help. I like teaching. My partner and I, Xavier and I, we like teaching. So that's what I'm teaching. I'm a very busy person. If I should open my WhatsApp mail, you see the number of messages I'm receiving. So many messages. Until I'm sacrificing my time to help you so I will study and go and pass. Now, no, me and myself, my dad, you're not even paying me a peso. You're not even buying bundle for me. You're not buying bundle for me. Me, I'm sacrificing my time to teach. You sacrifice your time to study and go and pass your own exam. So me, I'm not writing this paper. Also, oh dear, bro. If I'm to charge you for teaching, once I was only preparing a document for somebody, I charged a person 1,000, and the man was crying. 1,000, no soon. Also, wait, you have 300, and he sent the money because she's my girl's. A friend is saying my girl's boss at work. One of my students, the girl who called me, she's one of my student bosses at work. Into the and she paid 300. Mitrim ya deal name you. Me bob obeson die na me sikan kwa na so die. Ebo me born. And the work I use just 2 minutes to do it. Just 2 minutes. And I charge him 1,000 Ghana cedis. Just 2 minutes. So when you the girl was telling me, oh, please do it for him, let him see the work so that he will pay. So when you or say own to me, I was work this I don't know cancer. I the main cancer. Baby man. So when I'm teaching for free, cherish and appreciate it. Okay, so I'm doing normal distribution here. Go and study and go and play and go and get F. F is fail. Over try 1 year later. People write it twice or thrice, they still fail. Normal distribution. Pay attention. So here, I've explained the characteristics of a normal distribution curve or diagram, and I've explained what is called normal distribution and what is called standard normal distribution. I've explained them. Pay attention. Now, we are going to solve the question. Have you remember this, right? Do you remember this?
Yes, please.
Hey, Sisiana me chas you and be ye mama ke kama adwen kyerɛw. Enyi Sisiana me cha de we asa me de question 10 by am we film. Don't forget it, we are going to use it. So number 1, let's start. Somebody should read it for us. Oh. Yes, somebody should read it for us. Where is Dan?
Number 6. So shall I read?
Yes. Dan, what program are you reading?
Accounting and finance.
Okay. Continue.
Okay, so the A. Calculate the coefficient of variation for each unit and identify the more consistent unit. B. For unit A, calculate the probability that a call takes I less than 15 minutes and II between 9 and 15 minutes. C. For unit B, calculate the probability that a call takes I more than 18 minutes and II between 13 and 17 minutes. D. If unit A handles 1,000 calls and unit B handles 800 calls, estimate the number from each unit expected to exceed 18 minutes. And the company promises that calls will be completed within 18 minutes. Identify the unit more likely to the promise and justify your answer statistically.
All right, let's continue. So let's read the top.
Okay, a call center has 2 service units. Customer handling times are approximately normal distributed. So the table, service unit, under the service unit, unit A and unit B. Under the mean time, 12 minutes and 15 minutes. And under the standard deviation, we have 3 minutes and 2 minutes.
All right, thank you very much, Dan. Let's continue. Now, 1, we are
So,
starting.
please,
Pay
I'm done.
attention. Right, thanks. Now, it is a normal distribution. I get in it. How do you know it's a normal distribution? For most normal distribution questions, they will give you the mean, they will give you standard deviation. They will give you the mean, they will give you standard deviation, normal distribution. Or they can state it here. It says it's normally distributed, so it's normal distribution. Like I said, they'll give you the mean, they'll give you the standard deviation. And here there are 2 units, so we'll calculate for each of them separately. We will do for this, then go and do for that separately. Okay. Calculate the coefficient of variation for each unit and identify the more consistent unit. So coefficient of variation, there is a formula work. We call it CV. CV, your CV. And the formula is the standard deviation all over the mean. There's a formula for coefficient of variation. So we'll do it for CV unit A. Then also come and solve for CV unit B. The same formula. The standard deviation over the what's the name? The mean. Guys, you get it?
Yeah, sorry, sir. Is there no maybe there is times 100% or it's not necessary?
Okay, we can add times 100%. That's correct.
Okay.
Even if you don't know the formula, it should be in the formula sheet here. Let's check here. I hope they brought it here. Here is it. CV. The S here, yesterday we learned that we have 2 types of, we have the sample, right? We have the sample data collection. We have the population. So if you see S is a sample, I use this representing the population. Then you multiply all by 100%. So this is the formula. I can just pick the formula. When you are answering, you pick the formula from the formula sheet. They don't give you mark for the formula sheet, for the formula you picked from the formula sheet. So you can just come and pick the formula from here and we'll write it here. So we are on question 6. So question 6. We have the CVA, which is, you can use the S or the population, whichever one you want to use. Let's see whether the data is a sample data. And yet will be tracked. Why? So normal distribution. A course data has 2 service units. Okay, we can use any of them. Calculate the variation. Okay, can use any. Can use the S. Let's assume we pick it from the formula sheet over X times 100% for the CVA. Okay. Okay, so let's go. What is this? The S stands for the standard deviation. The S, so sometimes they might write it this way, or you can see the population standard deviation is the same. Just at the top, this one is standard, this one is sample, standard deviation. Okay, so let's go. So what is the S for A? CV, the A. This is the correlation, coefficient of variation for unit A. Are you getting it? Or we can write it this way if you think you'll be confused. Then write it simply. Unit A, right? CV is equal to S over X times 100%. What is the S for unit A? Unit A has the S. This is the S. And this is the X bar. This is a symbol for mean. X bar. And the standard deviation is S. Or we can use the population standard deviation. So it's 3 minutes over 12 minutes. Are you good? So 3 over 12 times what? 100%. What do we have?
25.
What?
25%.
If you write 25, you are wrong. You have to bring the percentage. That's it. So let's go to unit B. What is the standard deviation for unit B? 2 minutes. The mean is what? 15. So 2 over 15. What do we have?
13.33.
That's it. CV. You're done. Let's go to the B. Good. The B is where the work is. That's it. The B is where the normal distribution starts. Now B. Here is this one is very packed. B. Let's start with unit A first. B is unit A. So unit A says, for unit A, calculate the probability that a call takes less than 15 minutes and between 9 and 15 minutes. So you can see it's still coming by with the same less than and the between thing we learned. That you have to master. You have to write notations. You have to learn how to write notations. That's what I showed you the technique in writing notations. Here they use less than. Other time they were using fewer than. Other time they were using not more than or no more than. Other time they can say to the left of 15 minutes. They can say to the left of 15 minutes, lower than 15 minutes, fewer than 15 minutes. I getting it? Less than 15 minutes. So they can use different words here. Fewer than 15 minutes, less than 15 minutes, to the left of 15 minutes, below 15 minutes, under 15 minutes. They are representing the same thing. Are you getting it? Are we getting it?
Yes, sir.
So the phrase less than, they could use different phrases to represent or words to represent the less than. You have to take note of everything. So under unit A, we'll go to the unit A, these people. We are going to look at these people under unit A. They are for unit A. So let's write some keys we need. We'll say unit A, the mean is 12 minutes. So unit A, mean, 12 minutes. Then the standard deviation is what? 3 minutes. We need this. And what have we been asked to solve under A, the I? The I is we have to find what? Less than 15 minutes. Probability less than 15 minutes. So we have to find probability in the brackets less than what? Less than what? 15 minutes. This is what they want us to find. Let me write the notation. The notation will be P in the brackets. something we don't know should be less than 15 minutes. So what do we use to represent the something we don't know? We use X. Do you get it? Do you get it?
Yes, sir.
Yes.
So they said probability into bracket less than 15 minutes. I just pick this less than 15 minutes and place a P at the back or a P before it. That's all. But you have to write it notationally like that with the inequality less than. And I'm saying the word or the phrase less than, they can use different things to represent less than. They can use lower than 15 minutes. They can use below 15 minutes. They can use under 15 minutes. They can say to the left of 15 minutes. They can say fewer than 15 minutes. Are you getting it? They are all words which can be used to replace the less than. So you have to take note of that. Let's proceed. So after that, what we do is you first draw the normal distribution diagram, this one, using the X. So you could see here, X is what? They said this is 15. Some X value is less than 15. Don't forget this X is also, this 15 is also another X. By some X whose value we know. But this other X, we don't know their values. So we're going to draw a first normal distribution diagram. I said we will draw two. We're going to draw a normal distribution diagram using the X, this diagram. So when we come, we'll draw it this way. Then during listing the characteristics of the normal distribution, we said what? The mode, mean, and median are the same. So number 7, you can add number 7. The mode, mean, and median are located at the center of the diagram. You can add that. The mode, mean, and median are located at the center of the diagram. So 1, the mode, mean, and median are the same. That is 1. Then the mode, mean, and median are located at the center. That's why I wrote 3 M's here. I'm using yellow. That's why I wrote 3 M's here. 3 M's here. Meaning all of the 3 are located at the center. The mode, mean, and median are the same. So there could be some questions where instead of writing mean, they can choose, they will not write mean. They will write mode. Instead of writing mean, they will choose not to write mean. They can write median. And you'll be like, hey, they didn't give me the mean. So you take it as if it's the same as the mean. Because why? The mode, mean, and median are the same. So if I see median here, if I see mode here, if I see mean here, it represents the same thing. Do we get it? Do we get it?
Yes, sir.
Good. And now look at this diagram. So you could see this is the normal distribution diagram. The mean is located at the center. So the diagram I'm going to draw, the mean I pick for unit A, which is 12 minutes, it will be at the center of the diagram. Because it says they are all the same. So here we said the mean is 12 minutes. 12 minutes. So I write 12 in the middle. Am I getting it? Then X, I said that we have to find X is below 15. But before we can find X is below 15, we must first find X is equal to what? 15. Because this 15, I told you, it's like it's an X. But it's an X whose value we know. And we are trying to find other X's whose values we don't know. So looking at the normal distribution diagram, the y-axis, the horizontal axis, where I've written the 12, the figure 15, does it come before 12 here, or does it come after 12? When I'm doing numbering, does it come before or after 12?
After 12.
It comes after 12. So what you do is that you just mark it. Just mark anywhere on the number line. You mark here and write 15. Mark it. It should touch the x-axis, and it should touch the curve 15. Right? So we've marked x equals 15. But the question, are we to find x is less than 15? No, we have to find x equals 15. Which one? Are we to find x equals 15 or x is less than 15?
X is less than 15.
It's here. Why are you confused? It says less than 15 minutes. And what is less than 50? We don't know what is less than 15 minutes. So let's use X to represent minutes which are less than 15. So we are finding X is less than 15. But before you can find X is less than 15, we have to find X equals 15. So what we have just plotted here is called X equals 15. So if you found X equals 15, it's just like what we're doing. Some people are getting confused. Watch. If I want to find here, if I want to find X is less than or equal to 3,000, this is what I'm to find. Before I can find X is less than or equal to 3,000, I must first find X equals something, X equals something, X equals something, then add all together before I can find X is less than 3,000. Have you seen it?
Yeah.
I'm to find X is less than or equal to 3,000. But I cannot find it directly without the use of X equals this, X equals this. It's the same way. I'm to find X is less than 15, but I must first find X equals 15. And what I've just shaded is X equals 15. Now, let me find the X. Having found X equals 15, I can now find X is less than 15. So how do I find X is less than 15? It means when I stand on 15, go to where is this less than, which direction is it pointing to? Is it pointing to the right or left?
Left.
So when I stand on 15, which side is the left side of 15?
Towards 12.
Yeah,
portion.
so here, it means from here. All these places are what? Less than 15, isn't it?
Yeah.
So that's the diagram. So this diagram, I should have first written what is called normal distribution. Normal distribution diagram. I should have first written it before drawing the diagram. Then I'll underline, then I'll draw the diagram. So if we represented it with the X, this is the X distribution. So this normal distribution diagram is also called X distribution diagram. Having found the X distribution diagram, back to this. So what I've just done is the normal distribution diagram. It was only one X value, but when I was drawing here, I used two X values. Now I want to transfer it or transform it or convert it to a standard normal. So I want to convert it from X to Z. What tool do I need to convert it from X to Z? What tool do I need? I need the Z-score, this Z-score. This Z-score here would enable me transform or convert the X to Z. So now I've just finished with the X. This is how the X will look like. Then I'll come to use the Z-score. And I need the Z-score. Because the Z-score, which will transform it for me. So I write here Z-score. It's a formula. Equals X minus the mean, random variable, all over the standard deviation. So here you see I'm using the population standard deviation. So this is a symbol for the standard deviation. This is the population. Yesterday I explained it. So go and watch yesterday's video on question 4 and you understand the difference between this one and the S. I explained it yesterday. So this is the Z-score formula. Let's check whether it's in the formula sheet. Remember, they will not give you all the formulas in the formula sheet. So you must also go to the exam source with some formula sheet in mind. Oh, sorry, there's some formula in mind. Let's see whether they'll give us the Z-score. They didn't give us the Z-score. That's why you have to learn them by heart. You have to know them. So assuming this should be your formula sheet in exams. The formulas or your formula sheet in exams. They didn't give you Z-score. So you have to know some of the formulas in mind. And it's not difficult to learn. It's not difficult. That's why you have to practice and be able to solve the questions on your own. They play. You are waiting till exams. When the semester started and I wanted to come and teach, some people, only 3 people would join. And I stopped because I know students, it's last minute a moment, is the time that they'll become very serious. Okay, so this is the Z-score. So the Z-score is simple. Let's do it. What is the X value in the whole scenario? What is the X value? X is what? 15. Do you remember that?
15 minutes.
Good. So X is 15. Minus, what is the mean? Look at it. Look at it. I will head your lips. You, this girl, I will head you. I'll head you, your lips. Lisa, I'll head you and your teeth will fall down. Have you forgotten I said we write the mean in the at the middle? Have you forgotten that I've written mean here? You. The difference between this mean and this mean is, pay attention. Lisa, I will head your eyes. I'll use sachet water and break your head. I'll use sachet water to break your head, Lisa. This X bar is called sample mean. This U is called population mean. So the U I've written here is population mean. The U I've written here is population mean. The U I've written here is population mean. So because I'm using population, that is why I'm also using population standard deviation down here. Guys, do we get it?
Yes.
Okay. Lisa, what program are you reading?
Business administration.
If you disturb my class, I will use sachet water and break your head into pieces. Sachet water. Okay. So let's continue. So X is what? X is 15 minus. Are you in the level? Are you in the study group?
I joined today.
Okay. So X minus what? U. Then over, what's the name? The standard deviation. So X is 15 minus the U. The U is the mean. Is the mean. And it's just 12 here. They give it to us in the question. This is the mean. This is the mean. They said it is 12. So here you are using the population mean, not the sample mean. And here too, you are using the population standard deviation, not the sample. We are using population matters here. So 12 minutes for unit A. And we are working on unit A. So 12. You write it there. 15 minus 12 over, what's the standard deviation? I'm using the S to represent the standard deviation. So 3. What do you have in all?
1.
1. Pay attention. I said we are converting the X to Z. So just like this, just like the Z distribution, right? Now I've gotten the what? The Z value. So here, Z score is equals 1. So it's Z is equal to what? 1. Just like X equals 15. So it means in this question, in this case study, in this scenario, X has been changed to the Z and X was equal to 15. So here, instead of writing 15, what are we writing for the Z? It is 1. So X is Z, has been transformed to Z, and the 15 has been transformed to what? 1. Do you understand it?
Yes.
So in the question, are we to find X equals 15 or we are to find X is less than 15?
Less than 15.
So here in the Z side, are we to find Z? Is it Z equals 1? Is that what we are to find?
No.
Watch. I'm saying that we are done with the X page. We are done with the X page. We are now going to the Z. And we've transformed the X to a Z, right? So now, when we're dealing with X, we're dealing with X equals 15. Then I plugged it in the normal distribution diagram. Then we learned that we are not finding X equals 15. We're rather finding X is less than 15. So now we've transformed the X to become a Z. We've transformed the 15 to become 1. So I'm asking, here we're not looking out for, the question didn't ask us to solve for X is equals 15. It said we should find X is less than 15 or minutes less than 15 minutes, which is the X is less than 15 minutes. So if you've transformed the X to Z and the 15 to 1, are we solving for X equals 1? Are we solving for Z equals 1?
No.
What are we solving for?
Z is less than.
Z less
Very
than.
good. Z is less than 1. It's just like the opposite side of this. It's just the same as the opposite side. So we are solving for what? Z is less than 1. And this Z is less than 1. We are solving for the probability. So we'll put it into brackets. The notation. Have you seen it?
Yes.
Good. So when I wrote this notation, I wrote this X equals 15. What did I do next? I drew the normal distribution diagram. So here too, as I've done it, Z equals 1 and I've drawn the notation, I have to come and draw the standard normal distribution. Lisa, this girl, guys, speak to me because if she continues like this, she will see me in a hostel and I'll just cut her head off. So speak to me so that my temper will come down. Standard normal distribution what? Diagram. Are you getting it? When I got the what they asked me to find, I found X equals 15. Then I came to draw the normal distribution diagram and I plotted it on the graph, on the diagram, on the normal distribution curve. I came and plotted it. So here, the z-score will help me translate or transform or convert the x to z and the 15 to 1. But I'm not to find z equals 1. I'm rather to find z is less than 1, the probability of it. And after writing the z is less than 15 probability and x equals 15, I had to come and draw the normal distribution diagram. After finding the probability of z is less than 1, I have to come and draw the standard normal distribution diagram. So I explained that the normal distribution diagram, right, is for the x. Then when we use the z-score to transform it, it will transform it to become a z. The x becomes a z. When the x becomes a z, we draw standard normal distribution diagram. And the mean becomes 0. Here we don't write the mean of 12, because the mean of 12 will also change to become 0. Always is 0. So that's what I'm trying to do here. We've drawn the standard normal distribution because of the z. Then I would draw the curve. Those who graduated this year, when they were in level 100, their statistics exams was cancelled because some of the SRC people leaked questions to them. So I was there, and one of my guys, he was that time we've all graduated. So he contacted me that they want somebody to come and teach the students statistics because they have reset the exams for another time. So I should come and teach. And he called me and said, okay, you are my guy, so I'll come. And he asked me how much the SRC should pay. And so they should not pay me anymore. If I charge them, their head will ache them. So I went to teach them for free for 2 days. And when I was seeing them normal distribution, I was drawing a diagram like this. And I gave them assignments. So when I solve one, they will solve one. For example, here, I'm solving the B, right? I'm solving the unit A. So if I were teaching you physically, as in face-to-face, I'll solve the A. Okay? I'll solve the A. And based on the way I solve the unit A, you guys will solve the unit B for me to see. So I was going around inspecting the students, drawing normal distribution diagram. And the things that people were drawing right, the guys and the ladies. Some were drawing certain things like, I was even shocked. Those who graduated this year, some were drawing something like this. Do you see what I'm drawing?
Yes.
How can you draw normal distribution curve like this? The what is in red? So then I'm draw the book. Some were even drawing plateau. Some were drawing, some of the students. Some guy draw something like a cowboy hat, like this. Plateau. Plateau is a mountain with a flat top. Some are drawing, and I tell you, look at what I've drawn, but look at what you are drawing. Okay, so let's continue. So I'm drawing the standard normal distribution diagram. It is also called the Z distribution. This is called the X distribution. This is called the Z. So the Z, I come down here, I draw the symmetrical line. The mean here is 0. Don't go and write 12. In the X, it is 12, but the Z, it is 0. Then X is what? Z is what? 1, right? Here. Z is what? 1, right?
Yes.
Good. So if Z is 1, the 0, the 1, does it come before 0 or does it come after 0? The 1.
It comes
So after 0.
It comes after 0. So I'll come and plug the 1 here. Always make sure the markings will touch the horizontal axis and the curve. This 1. Then when it is 1, did the question ask us to find Z equals 1 or Z is less than 1? What did the question ask us to find?
Z is less than 1.
And don't forget, Z equals 1 is the same as X equals 15. And Z is less than 1 is the same as X is less than 15. Don't forget it. Because if you go and write X, you go and repeat your X again, you fail. Z, right? So this 1. So now, and we have to find to the left or below 1. So we look at the 1, the arrow, the inequality. Is it facing the left or right?
The left.
So you shade. You shade it. We also have to boss a make sure they are Matome boss a make sure you better say Lisa unya vin I will kill you. We only ma they meet my own. Mete yes say Dan try B+. Hey, I'll come and remove your brain and chew it and add it to my brain. Try me. So I'm to me boss say share what DM. Or lecture or chair or not yes sir.
Dewi.
Into my Tommy boy, well, I know how students are. Not that they cannot, some of them cannot teach you to understand, but my Tommy boy such, and I'm teaching all the techniques. So don't say, oh, someone not taught me, I've understood. So when it comes to exam, I can be able to do it. Oh boy. Until you sit down and practice, master. And I've showed you even the chartered accountants, those who are the CR I taught you, the final level of professional, they are their senior level chartered accountant. I was writing the saying that if you cannot solve the questions the lecturers are solving with you on your own, then in exam you cannot solve such questions. If similar questions are set in the exam, you cannot solve it. Where I may want to say and go and revision, pick the same question and solve it on your own. Then in exams, when they repeat these same questions, you cannot solve them. You'll be making mistakes. You don't even know what you are writing. What am I writing? Because you didn't sit down to study. You didn't sit down to practice. Education is not difficult, but it's not as difficult as going for hookup. You can sit down, study hard, and pass, and it will expand your brain than going for hookup for grades. You didn't know the number of issues I'm at with school more. Since 2021. Just give it a since 2021. Since 2021. How many years now? We are in 6. We are in 2021. 6, right? 6. So let's say 5 years. And I've taught so many students, plenty. Is it 2021? Let's say 2021. And I've taught so many students, so many. I've showed you some of them. So many students. Those who graduated this year, last 2 years, last 3 years, last 4. I've just taught so many of them. This is the Z. We mark the Z. Z equals 1. So this 1 is for the Z. And we are finding below the 1. So below the 1 is to the left. So you shade all the region. Are you getting it? Are we getting it?
Yes.
Yes, sir.
Now, let us go and solve the main question. So, just as we were solving this, we are like, the whole work, let me show you the technique. The whole work about normal distribution is like back and forth. You come back, you go forward to this step. Then when you get to some point, you have to come back to a previous step. You have to leave the present and go back. Then if you leave the present and go forward, that's how the work is. So it's back and forth, back and forth, back and forth, back and forth. That's how the work is. So you see, we have to find x is less than or equal to 3,000. We must first find x equals 0. So if you want to find x is less than 3,000, first go and find x is equals 0, right? Or x equals that number. You see it here. Here. This x is less than 3,000. Look at the figure. X is equal to what? 3,000. Then we added all of this together, inclusive of the 3,000, before we go the x is less than or equal to 3,000. So here, we have to find x is less than 1. Probability of x is less than 1. Before we can find the probability of x is less than 1, we must first find probability of x, z equals 1. Now we are not dealing with x again. Before we can find the probability of z is less than 1, we have to first find the probability of what? Z equals 1. Just like the less than 3,000, you have to go and find x equals this, x equals that, then add all before you go the less than that. It's the same thing here. So we want to find the probability of what? Z equals 1. And don't forget, this probability of z equals 1 is the same as what? Probability of what? X equals 15. Do you remember it?
Yeah.
Yes.
Yeah.
But yeah, just write the Z1. I just want to do this for you to remember it. It's the same. Just that this one is normal. This one is standard normal. So to find the probability of z equals 1, we write equals. We'll go to the table, the Z table. Let's go to the Z table. Let's go to the Z table. So this is the Z table. Is that it? This half table. Okay, let's see if this is. Okay, let's pick this one. Let's pick this one. This is a half table. Let's pick this one. Let's pick this one. So here, watch. Z equals 1. So we will find 1 on the vertical axis, this axis. We are going, this is the Z. We are going to use the vertical and horizontal axis. The horizontal axis, we use it when the figure is after the decimal point. But these figures here, we are looking for the figures which are before the decimal point. So Z here, we have Z equals what? 1. We can say 1 is the same as what? 1.00, right?
Yes.
Good. So Z, let's find Z here. 1.00. Where is it? This is it. 1.0. Is that correct?
Yes.
So 2 decimal places. So we have 1.00. And we've seen 1.0. What else is left?
0.
Good. So we've seen on the vertical axis 1.0. This is it. This is what I've circled. 1.0 here. What else is left? We'll bring another 0. That 0, we will come to the horizontal axis and check for the decimal places, which are what? 0, 0 decimal places. So which one has the decimal 0, 0 decimal places? Is it the
0,
first
0.
one?
Yes.
Good. The first one has 0, 0 decimal place. So it's 1.00. That's it here. Or if you don't understand it, let me add 1.0 to 0.0. So look on the right. 1.0 plus 0.00. 1 plus 0 give us 1. 0 plus 0 is 0. 0 plus 0 is what? 0. Do you understand it?
Yes.
Good. So where do they meet? Where do they meet? Where do they meet? This is 0. It comes down. Wherever we see 1.0, we stop. Is it one? It's 1.0 here.
Yes.
So this is where they meet. So this is the area. Now, all the figures we see here, they are all probability. They are all probability figures. So when the question says the question could be like, go and find the area, go and find the probability, go and find the percentage, go and find the proportion. They all refer to going to find the area. That's why here it's called what? The areas under the curve. Areas under the curve. So the figures you see, not the 0, not the horizontal 0, 0, bolding 0, 0, not the one. Not Z, no. The areas are the probability figures. So we said the highest probability is what? Is 1. And the lowest is -1. So you could see that I start from 0.5 and ends at where? 0.9. It is not even exactly 1 because they are all probability values. So when the question says that, question exam bar, oh Charlie, question now was straight. Now you was so watch. The question says B. For we've done A, we are on B. For unit A, calculate the probability. And I'm saying some of they will not say probability, they can say calculate the proportion, calculate the percentage, calculate the area. They can use any of these words. If they, whichever word they use, probability, proportion, percentage, area, first use normal distribution. It means it's about when it sounds like this. Fina, I asked of you, we're not in the class.
I just joined.
Nonsense. So if you just joined, do you want me to go and start? Yesterday, I told you. Yesterday,
No,
those who were
not
here,
really start. It's just there from maybe the A or
you are lucky.
I just came back from work. Sorry.
You just came back from work.
Yes, please.
Mate. So I'll finish it and I'll upload it on the channel that you watch. Okay.
Okay.
And then you watch.
Thank
So
you.
wherever you got into, just put your offering in the offering bowl so that you worship with us.
All
So when
right.
I'm done, what program are you reading? Is that marketing?
Yes, please.
Mate. So just follow. So I'm saying that they can say proportion. I thought you were here and you were saying you didn't understand. I was going to give it to you front and back. Probability, you can say calculate, the question would be calculate the probability, proportion, calculate the percentage, or calculate the area. When they say that, it's simply saying that follow the same approach and come and find the probability here. And as I said, everything here in the data, everything here in the table is probability. All the values here are probability. That's what they want you to find. Everything here is also called the area. Everything you are seeing here is talking about the area. Are you getting it? Are you getting it?
Yes.
And also, everything here is also probability, is area, is also called proportion. And it's a percentage. It becomes a percentage. When I pick like 0.69, when I multiply by 100%, what do I have? 69.5%. Is that correct?
Yeah.
So I can only get the percentage if I find the probability. And the probability is here. And I multiply by percentage. That's all. So let's continue. So now, from what we are learning, the 1.0, it is 0.8413. Are you good? 0.8413. That is the area we need. So I'll come here. That probability of Z equals 1.0 equals P equals 15 equals what? 0.8413. Write all the four decimal places. 0.8413.
Okay, sir.
Are you getting it?
Yes, sir.
What it means is, pay attention. What it means is that, look at the diagram. What it means is that from 0 to 1, you see 0 is below the symmetrical line. So from 0 to 1, the distance between the 0 to 1, the area, that whole area, let me use yellow so I can see it. That whole area between 0 and 1, this whole area between 0 and 1 is 0.843. Do you get it? No. It's too huge. No, I'm using the wrong curve. It's too huge. I'll explain why it is too huge. Let me see. I think it's this one. Is this half table? This is a half table. So this is what I will use. I'll use this one. Yeah, it's this one. 1.0. This is 1.0. It should be X, Z here. 1.0 and 0.0. It is here. Right? 0.13413. It should be X. It should be Z here. I get it. It should be Z here. So it should be 0.3413. Not the first one. The first one is more than half table. The first one is more than. You see here, they've written what? Half table. Half table. I'm using the half table approach. Half table approach. Let me see. Well, I'm coming.
Yeah, I'm
Let me see what I can
confused.
get. Yeah, hold on. Let me see what I can get a past question for you so that you see what I'm trying to say. Statistics. Good. So watch. This is what I'm talking about. Watch. So this is a past question. This is 2021. Can you all see it?
Yeah.
Good. This is 2021. So watch.
Yeah.
Statistics. I'm going to the formula sheet. Bema. So look at it. Have you seen I'm using red. They said standard normal distribution table. It means it is a Z table. This is a Z table. And this is Z table, right? And this Z table, the kind of sheet they'll give you. This Z table, our final answer was what? 1.0. So let me clear this one. I'll show you why this 0.8 is wrong. Let me cancel it so that when I get that, I'll explain. I'll show you why it is wrong. So here, this is a Z table. So we are looking for Z is equal to 1.0. And we got it here. 1.0 is here. There's 1.00. And the 00 is up here. So where they both meet, they meet at 0.3143. Have you seen it? So when you come here. So you see, this is, instead of writing Z, they really wrote X to confuse the student. So 1.0, 0.0, what do you see? 0.3413. Have you all seen it?
Yes.
So that's why, so this is a half table. So that's why it is correct, because this 0.3413 is the same as the Z here, 0.3413. But probably they want to confuse the student. So instead of writing Z, they made it an X. I get it. So this is what we should use, not the other one. Not this one. This is a full table. Pay attention. Wait. This is a what? This is a full table. Have you seen it? Have you seen it? This is a full table. So here, this is part of the full table. Let me show you something. When I write a number line, right? 0 is in the middle. To the left of 0, what do I have? Negative values, right? Right?
Yeah.
And to the right of 0, what do I have? Positive values, right?
Positive.
So if I'm drawing a normal distribution curve like this, and it's a full normal distribution diagram, it means that it will start from negative and end at where? Positive. That is why here, starting from negative 3.4. So this is the one half of the table, the left side of the 0. Are you getting it? Then it goes, it continues, then it comes to meet 0.0. This, are you seeing it? negative. Then you start from the positive. Then it goes to the, so this is the other half of the table. Are you getting it? The other half of the diagram. Do you understand it now?
The table, is it up and down?
Yeah,
I'm
this
not
one is a
familiar.
full table. Watch. I said this one is a full table. This one is a full table. Are you getting it? So full table
Yeah.
is like, watch, this is the normal distribution diagram, right? The middle here is
Yeah.
what? 0. So to the left of 0, is it positive or negative?
Negative.
So
Negative.
it's negative here. To the right is what? Positive.
Positive.
So if they said that the table they've given you is a full table, it means it will start from negative on the left side of the 0. Then it will proceed, it will continue negative, it will be declining. You see here, you have negative 0.0.
Yeah.
We have negative 0.0 here. Then here too, we have positive 0.0. Are you seeing it?
Yes.
So it means they started from negative. Look at the diagram. It started from negative here, and they've come to end at 0. So all the values here are negative. Then after this 0, the other figures on the right will be positive. So after the 0 here, have you seen all the other figures are positive?
Yes.
So this is a full table. I don't need a full table. I need a half. This is a half table. That's what they wrote here, half table. And I'll show you why I need a half table. Half table means that this. Okay, look at this figure. This is a very perfect example. Look at this figure. You see we have negative 4 here, right? Negative 3, negative 2, negative 1. Have you seen it?
Yes.
And here is what? 0. Have you seen it?
Yes.
Then 1, 2, 3, 4. So when you say symmetrical line, when this middle, when I cover the diagram, assuming I fold the diagram, the 1, on which value on the left will the 1 fall on when I fold the diagram?
-1.
Negative
Good.
1.
This 1 will follow -1 because it's symmetrical. So these 2 also fall on what? -2.
Negative.
These 3, good. So it means that if I find 1 here, if I find z equals 1 here, and the figure is positive, then if I fold it to the left, that same figure will become what here? Negative.
Negative.
That's why I will use a half table. But if you want to use the full table, what I was trying to use at first is a full table. So full table, we learned that in the normal distribution diagram, the symmetrical line, on the right side of the symmetrical line, what is the total area under the curve? On the right, what is the total area under the curve? The whole curve. The whole area under the curve.
1.
What's the total? 1.
1.
So if I divide the 1 into 2, the right side will be how many?
0.5.
0.5.
And the left will be how many?
0.5.
0.5.
So if the right side will be 0.5, and from 0 to 1, it should give me less than 0.5 because it's not covering all the area. Do you get it?
Mm-hmm.
All the right side of the normal distribution curve, if I draw it this way, right? Let me draw it well. I want you to understand. That's why I'm over explaining. Watch this. We said the whole area is 1. When I divide it into 2, this whole right side from here to this area, everything here is 0.5. But look at where the 1 ends. Does the 1 cover the whole 0.5?
No.
No.
No. You see there are spaces here, right?
Yeah.
So it means that the distance from 0 to 1, it should be less than 0.5 because the 1 is not covering the entire 0.5. Do you understand it?
Yes.
So when I find the P equals Z equals 1.00, it gave me 0.8. That told me I'm dealing with a full table, not a half table. Because if it's a half table, and I want to only find the half side of the diagram for 1, and 1 is not covering the entire 0.5, it shouldn't give me 0.8 because 0.8 is more than half, isn't it?
Yes.
Good. So it should give me a figure which is less than 0.5 because the 1 is not covering the entire half of the curve. It's only covering a portion of it. So you give me a figure which is less than 0.5. But here I was getting 0.8. That's why I got to know the table. I was using the wrong table. Do you get it?
So I have a question.
Okay.
I said yes because the 8 is more than 5. But being the case that is less than 5, does that mean we have to use the half table?
Yeah, that's what I'm driving at.
Okay.
Because we are only using half of it, half. and the whole half is 0.5. If the whole half is 0.5 and the 1 is not covering, look at the shaded region for the 1, the yellow shaded region. Do you see me shading the right side of the 1? The right side of the 1, do you see me shading it?
No.
No.
No. But from the yellow diagram which is on the right, I have shaded all the empty spaces that is the 0.5. So if all the empty spaces on the right side of the yellow diagram is 0.5, and 1 is not covering all the empty spaces, but it's covering a portion of it, it means that the probability of the 1 should not be more than 0.5 because the 1 is not even covering all the spaces. Is that true?
Yeah.
Good. But when I went to the table and I picked one of the tables, it gave me that it is 0.8. That's why I go to now was wrong. Because I have to use half table. So just like this is how it will be in the exam, this will be your normal distribution table. It is what? Z is here, 0.343. And when we come to your table, it is this Z also, which is given as the 0.343. So this is the correct table to use. I should use the half table. Are you getting it?
Yes.
There's another way I can use the full table. So I will solve that one to use sales. So let me write this 0.8 here. I'll come back to it. But for now, let me clear. Okay. So from the table, our Z, probability of Z is what? 0.3413. 0.3413. Are you good? So have you seen that the Z equals 1 is 0.3? It's less than 0.5. Have you all seen it?
Yes.
So this is the correct one. So what this means is that from the distance from 0 to 1, the whole area where I've shaded yellow, the distance, it is 0.3, which is less than the entire area of what? 0.5. Good. That's what it means. So are we to find, did the question ask us to find P into bracket Z equals 1? Is that what the question asked us to find?
No.
What the question asked us to find?
Z less than 1.
Yes, the question said we should find Z less than 1. So P into bracket Z less than 1. And Z less than 1 is the same as what?
1. 0 point.
I will head you. Hey.
X less
If,
than
if,
15.
thank you very much. I'll give you 20 pesos.
No, dude.
P, Z, I said Z equals 1 is the same as X equals P equals X equals 15. And P, Z less than 1 is the same. I said the Z is the same as what? The X. And the 1 is the same as what? The 15. Right? And the less than. So this is what the question said we should find. Do you get it?
Yes.
Do we get it? Hey, do we get it?
Yes, sir.
The X people, they are called normal distribution. And the Z people, they are called standard normal distribution. Are you getting it? The X people are called normal distribution. It's here. These are the X people. And we change the X to Z. So when we change the X to Z, the 15 was also changed from 15 to become 1. So Z equals 1 is the same as X equals 15. Then Z is less than 1 is the same as X is less than 15. Do you understand it now? Okay, so let's finish it. So now, watch. For us to find Z is less than 15, right? What we must first find is that we must find P into bracket Z is equal to 1 plus, watch. Why must we find? Because the whole area we are finding, I'm using blue, watch. The whole area we are finding is from the 1 here downwards. And the 1 here downwards from the symmetrical line down to the left. What is the area for the A? What is the area of the symmetrical line to the left? What is the area? What is the total area there? What is the total area under the curve?
1.
Okay, so watch. From the symmetrical line to the left, what's the total area under that? What's the area under that curve?
0.5.
0.5.
So pay attention. From the zero, this zero to the left, the whole area is 0.5. And what is the area from 0 to 1?
0.3413.
0.3413. And the question says we should find the total area below 1. The total area below 1. So if you have to find the total area below 1, what will be the total figure?
You add the
Add
0.5
it to
to the
You add this to this,
0.3.
right? You
Yes.
add this to this,
Yes.
right? When we
Yes.
add this to
Yes.
this, we'll get this figure.
Mm,
The
yes.
full table. The full table, yeah. But the half one, let me teach you the half one. So it means that for us to get the total area under 1, we have to add the PZ equals 1 area. This one is the probability. This is the probability, which is the area. We have to add the area, which is this figure, plus the 0.5 on the left side. So when I'm adding it, it's going to be 0.3413 plus 0.5. The total area will be what? 0.8413. So that is what we get in the full table. So the full table will add everything for me, and I'll just write the answer. But
so
mostly
is it
they don't
wrong to
like.
use? Is it wrong to use just go straight and use the full table so that or I should still use the half and then come back?
But mostly they give half tables.
Oh,
Most
okay.
exams questions they give half. You see, this is the formula sheet. Then they'll give you a half table. Mostly they give you half tables all the years. They give the half table. So you must know. How do you know it is a half table? Sometimes you see all these figures start from 0.0. I've seen it start from 0.0.
Mm-hmm.
So they gave you the positive side of the half table, and it ends at 6.0. I get it. I don't know if you guys
Yeah.
watch. You watch. Teach you something. Watch. Hey, is my laptop frozen?
I think so.
Hey, you want us to win the session, then you go and eat banku and sleep. Okay, it's back. Let's continue. So
So will
watch.
you come to campus on Saturday?
Who?
You.
Oh, no. I'll start when now that the masters and the 400s have resumed, I'll be coming to teach them. Or
So
sometimes I teach them
Saturday will
online.
we see?
This Saturday,
Yes, please.
okay, maybe if I'll come and teach you guys economics.
We have statistics on Sunday.
Oh, but I have all the videos. So go and watch the videos. I have all the videos on the questions. So today I've solved question 5 and question 10. So watch the
Wow.
videos and you'll be okay. You'll be okay.
Okay.
Now that the masters and the 400s are in school, they will resume next month lectures. I'll start coming to campus second week in September. But I'll come
Okay.
and teach them. So that's it. So let's go. So see what I'm trying to say here. One is a half table. It began with 0.0. So look at this. Look at this one. This is the full table. And I said the full table starts from negative. Look at this. -3, right? And they said it's a full table. So -3, it comes down. It ends at -0.0. Then when it ends at -0.0, continue it what? +0.0. It's a continuation. So this zero part, this part, which is the 0 to the positive side, right? That is what they've captured as the half table. Are you getting it? Are you getting it? So when you say half table, we start from there. They can give you only the positive side, or they can make the Z, they can make all the figures negative. But don't forget that if it's a half table and it's negative, when you fold it, it will fall on the other side as positive. That's what I explained here. Do you remember?
Yes.
So sometimes they can give you this table they've given us, which is the half table, is the same here in the question, but do not write that it's a half table. You must know it's a half table. And I'm saying that the figures say which are the half table, they can give all these values as negative, half table, but they'll make it everything negative. And if they make it negative, remember the diagram that if you fold the negative to the right-hand side, -1, on which value will it fall on the right-hand side?
+1.
So it means that if you, for example, here we are looking out for z is equal to 1, right? We are looking for z is equal to 1 here. The z is equal to 1 here is the same as z is equal to -1. This z equals 1. In the half table, it's the same as z equals -1. Because when I fold the +1, it will fall on -1. So sometimes the table, they can make all the z values negative. Meanwhile, it's half table, but they will make all negative. How do you know it's negative? They will say -0.0, and they will end with negative. They will also end with negative. So you know that everything is negative. So just like this, they can say -0.0, -0.5, till -0, -6.0. You don't see anything positive. Then it means that it's a half table. Here you are seeing only values. It means that it's a half table. When you also see that they are all negative values, it means that it's a half table. So if they are all negative values, then this thought should come to mind. When I fold it, it is positive. So if they are -0, -0.1, it's the same as saying it is 0.1. If it's -1.0, if it's a half table, it's the same as 1. Are we good? Are we good?
Yes.
So most of the questions, they will bring half tables. So you have to master the half table. So we'll be using this to solve the question. Let me finish. The time is really running down. So we have to find P into bracket Z is less than 1. And it's the same as P into bracket X is less than 15. But X is less than 15 doesn't give us the area. It is rather the Z which gives us the area. So we will have to change the X. We have to convert the X to a Z so that we will go to the Z table and find the area. Because if you cannot go to the Z table with an X, because here we don't see anything X here, everything here is Z. You will not find 15 here. I get it. You will not find 15. When we were solving, we said X was 15. But if you come and look on this table, you will not find anything like X is 15 here. So you have to change your X to Z. And the Z will bring you to the table. And when the Z brings you to the table, you are going to search for values which are here. You are going to search for these probability values. Everything is probability. The probability here are the areas. They are also the proportions. They are also the percentages. Then use it to come and solve your work. Are we good? So if the question says we should change this one to a percentage, you just multiply this by 100%. What do you have? 84.13%. Is that correct? Is that correct? Hey, hello, is that correct?
Yes,
Yes.
please.
And me, I should have ended the first session and copy this new one. Otherwise, the video will be very long. The video will be very long. Okay, let's go. Question 6. So we are done with the first one. Less than 15 minutes. That's the answer. Let's go to between 9 and 15 minutes. So who can write the notation for me? Between 9 and 15, how do you write the notation? I. Yes, between 9 and 15, how do you write the notation? Oh, between 9 and 15, how do you write the notation?
It's equal
Is I'll head you. Hey, we need to do this today. We did it here. We did it went far. Any. This is it.
P bracket.
P brackets.
G-
Less than.
X.
Hey,
9
Lisa,
Less
less
than.
than.
this lady, I've warned you and warned you and warned you. Class, if you see that somebody has divided her head into 2, it's me. I'll use sachet water. I'll come to her at the house and I'll break her head into 2. You should advise me so that I hold my temper because this guy is provoking me. This lady is provoking me in the class. P into brackets.
9
P.
less than x less than 15.
I showed you how you can write it. Just write between 9, write a P into bracket. It says probability. So you write a P. You open the bracket, then you write 9. Then the last one is 9 and what? 15. The next one is 15. Come and write 15 here. Then close the bracket. Then you write X in the middle. Lisa, are you looking at it? Lisa, are you looking at it? She has left the
Please,
class.
please, I'm here. I'm looking at it.
So 9, come and write. He said when you see the between, come and write 9. Between means X is between 9 and 15. Between means X is between 9 and 15. So I write the 9 first. He said probability of. So probability of, probability of. So of is times, and I'm using brackets. So P into brackets, that is P times. Then between 9, what is between 9 and 15? It is X. So 9 first, come and write a 15 second. Put X in between and put less than, less than. That's all. This is the notation. Are we good? Are we good?
Yeah.
Or you can I want to really make it quick. Inti more issues now. Yeah, class I'm on more train exams. Hey, you are lucky I don't have any serious. I have a meeting with someone anyway. More issue, yeah, class I will train exams. My church now. Why should I now be teaching you half table, full table, this, the when you You mean that if I had taken the question and solved it straight away, can be Raymond say. So don't wait. I was been having class. That discouraged me from having the classes with you guys. But when I organize it, only 3 people, 4 people, because they feel it's not exams time. If you do that and someone doesn't get the time to help you, you go fail you. School is not just go and write exams and pass. You have to understand the concept. Why do you think I'm explaining all this? Because I'm TSA and I've taught so many students, so many students, so many students. TSA. In Kenya, fair exams ever drew. You are even if I started around 5:30, it's 9. So about 4 hours. Make it 4 hours. So you cannot pay me. Obi work a cram here the 2 minutes. Me 1,000. Or aquano first or TSA me here work the money we and afina. Or bega say on no here then so when you pay we. So he's paying 300. And I said yes, you should give it to me. And I gave my girl 100 cedis to buy a time. The 2 minutes per me did 2,000. Now my child from 5:30 to 9:30, 4 hours. Share. Me, I charge per hour. My boys will they charge per hour. I keep quiet there. I charge per hour. If I'm to charge you, if you want me to come and teach you per hour, you pay 50 cedis for 1 hour. Now you pay me 50 cedis for 1 hour. I know my boys now, but I only do 20 cedis per hour.
We are students.
Yeah, that's not my business. So if you are students, that's not my business. That's why I don't want to come and teach students on camera. If I'm coming, the budget amount, because I'm coming to teach you, my boys can come and even teach you. My level 200, 300 boys. I'm coming to have a show. Now, let alone me. And I'm not taking time to explain to you all this, and you are wasting, it's taking so much time. So don't wait till you have 1 week to exam. Now, when you break, hey, who's I want to ask you? You have to understand the concept from the beginning of time. Now the cultural now the cultural in exams round because what you say if it were exams you all understand the concept. I can use 30 minutes or 40 minutes to finish solving everything. But I spent over 1 hour here just explaining one thing concept. I have to come and even teach you half table and full table. Hey, what kind of attitude is that? So don't do that next time. Next time, yeah, you see me organizing class, you see the link, you tell me you wait, you go and use chat. That's not my business. The way I'm explaining the chat will not explain it to you like that. And when you go and fail, it's your own business. I mean, when you fail, you don't fail. It doesn't add anything to me. It doesn't add any value to my life. So just pay attention. Don't wait. Next time, if I'm to solve a past question and I pay them, so if someone asks, someone I don't understand, I'll just fire you and I'll move on. Because I just like teaching and I want to teach you. But if I say you should pay me to teach you, you cannot pay me. That's just a word of caution. Don't wait till exams. You don't even know a half table and full table. You don't. Hey, that's just my message to you. And I'll not always have the time to be doing this. My mama boys, but make some discount. Make some muntia 10 CDs for him to come and teach you. When you are on by me, so I'll not have time for you. I have time. That's what I'm teaching you. But as my guys who come, they will need money. Everyone should pay 20 CDs, 10 CDs. Then when you pay 20 CDs, you come and start and he teaches you whether you understand or you understand anyway, because I'll give you the good guy. That's your something you should take note of. Go and watch the YouTube's all the videos. Okay, I can't go back. Now, let's go. For Unit A, calculate the probability that a call takes less than 15 minutes. We are done with it. Between 9 and 15. Who is between 9 and 15? It is X. Then you write the 9, which is the one first. Write the 15 and put less than. The other one we did, it was inclusive. If they say inclusive, then I'll introduce the less than or equal to, less than or equal to. But I said between 9 and 15, just 9 and 15. There's it. So let's go to the II, between 9 and 15. So II question is what? Between 9 and 15. This is what they want us to find. So still, remember that in the unit, the population mean is 12 minutes. Like first we'll do is the notation for the probability. So I can say that quick. I can P into bracket what? Between 9 and 15. Then I'll make it equals P into brackets, right? I'll write, pay attention, I'll write a 9 here, then I'll write a 15 there. Who is the notation? It is X less than. That's a notation. So when there are two like this, okay, remember, just like the previous one, this 9 is an X with a value. This 15 is also an X with a value. And we have an X whose value we don't know in the middle. So I can say 9, I can say X1 9. I can understand it. Hello. Hello.
Yeah, hello.
Yes, sir.
Hello.
It's on my
No technical.
finish. Hold on. When finish, go and watch here. You should understand it. Yes, the 15 look at after the X, but second X, you know what it is. That's what you're solving for. All the values, all the minutes, all is but one thing of the 15. But we don't know certain X. That's what we are solving for, the one in the middle. So this 9 is an X1, and this 15 is also an X2. Do we get it?
Yes.
Good. So here, from here, after I wrote the notation like this. I wrote it as X equals 15. That is what I've written here. After the notation, I wrote X1 equals 9, X2 equals 15. Then after I wrote this X equals 15, the next one is I wrote normal distribution diagram, and I drew the diagram. So here too, after writing X1 equals 9, X equals 15, I write here normal distribution diagram. Then you draw it. What is the mean? The mean comes to the middle. What's the value for the mean? Quick. What's the value for the mean?
12.
Have you all seen it? It's here, 12 is here. Look at the question. The mean, we are still on unit A. Here. The mean is 12. It's still 12. And where is the mean located? In the diagram, where is the mean located?
At the middle, center.
Yeah, at the center, in the middle. So I write the 12 here. Some of you want me draw diagram where normal distribution mean where if I only one thing fee no. To be show you now share the mean the middle. That's the 12 here. Now when I will draw it here as 12, the next thing is because I have x1 and x2, I'll first ask myself the x1 is 9. Then 9, does it come before the 12 or after the 12?
Before the 12.
So I'll mark it. I'll mark it before the 12. Mark it here. Now write 9 as what? X1. Then I'm done with the 9. The 15, does it come before or after the 12?
After the 12.
After the 12.
And then the list a trouble yeah, Jim. Or dear who say what them all. Only can contain child. After the 12 is what? 15. And I write here what? X2. That's it. And they said that, did the question ask me to find x1 equals 9? Class, did the question ask me to find x1 equals 9?
Yes.
No.
Hey.
Who said here? What's our saying? What's our saying?
Oh, I
Did the
said
question ask me
no.
to... yeah, what the matter? The question asked me to find x2 equals 15.
No.
No.
What did the question ask me to find?
Less than 15.
Then
It
Between
said
9
I
and
should
15.
find between 9 and
9 and
15.
15.
So this one, we'll say x
I'm
is greater than 9, but less than 15. So this between 9 and 15 is x, between these two. So the question I should find between 9 and 15. So where is 9? In the diagram, 9 is on the left, right, 15 is on the right. So where should I shade?
In the middle.
In
middle.
between
Shade
In between the
15.
diagram.
in
Yeah.
between. So I'll shade the 9 to the 12. I'll shade them like using the forward slash like this. And then on the other side, from the 12 to the 15, I also shave with the diagonal. So the 9 to 12 is the opposite diagonal, right? And the other one is this way. So in between 9 and 15, that is what the question says I should find. But if you finish with this, you cannot solve the question when you end here. That is why I was explaining that. When we use the normal distribution diagram, we use the X. Then we'll use the Z-score to convert the X to the Z. And when we convert the X to the Z, we no more have normal distribution. We have elevated it to what is called standard normal distribution diagram. So we'll draw another diagram. This is the X. Then Z-score. This is the converter. To convert or transfer the X to the Z value. And when I got the Z value, for the Z value, when the approach distribution, then from there, come and solve the main question. So what we have just done here, we have finished with the first part. This is the first part of the work. Now, what is the next part?
You find the Z value. Hey.
No, quiet. Shut up, quiet. What's the next part? What is step 2? I've written 2 again. What is the step 2? Z-score. Do you get it? The part 2 is the Z-score. Then the part 3, let me say, I'll come and find, there's a part 3, the standard deviation. Then the part 4 is where I start to solve the main part, the main work. So the part 1 is the X and the normal distribution. Then the part 2, you have to come and find the Z-score. So let's go and find the Z-score, the part 2. Z-score. The formula, they may not give it. So make sure you memorize it. Z-score. Yesterday, I told you, if you want to copy formulas, write them on your calculator, at the back of the calculator, using a pencil. If you go and use a pen and it gets stuck, remember you're in 1100, you're going to go to 400. You'll be writing a lot of formulas. So use pencil. Z-score is what? X minus the population mean over the standard deviation. This is the Z-score. So this is the part 2. After the X The next part is the z-score. So you come to the z-score. That's the second stage. Then what is the first? Now, how many x values do we have in this question? How many x values? Quick. How many x values?
2.
2. So first, we go and solve for x1. So x1 is equal to what? 9. So we'll say 9 minus the mean. What is the mean? 12. What is the standard deviation? 3. What does it give us? Quick.
The -1.
1. We're going to find x 15. So we replace it with what? 10 minus 12 over 3. And it will give us. Quick. Oh, guys,
So
quick.
it's
I have a meeting.
1.
Give us 1. So watch. This z-score, now, remember that this is z. This is z1. This is z2. Are you getting it? So now our z1 is what? -1. And our z2 is what? 1. So as our x1 is 9, our z1 is what? -1. As our x2 is 15, our z2 is what? 1. Do we get it?
Yes.
Good. So now here, this is what I've got into. Here, this is what I've got into. This is what I've got into. This is what I've got into down there. This is where I am. Here, we're only using one z-score. It was 15. But I'm using 2 z-scores. Z1 and Z2 because we have x1 and x2. So we have to find a z1 for x1. So if x1 is 9, the z1 is -1. If x2 is 15, the z2 is 1. Right? Did the question ask us to find z1 -1 and z2 1? Is that what the question asked us to find?
No.
So what did the question ask us to find?
Between 9 and 15. So between -1 and 1.
Good. Lisa, I'll buy you Tom. Guys, you understand it? We are what here say one co practice and you be fit because that's mathematics. One co tenase and draw and try to bit solving on your own. Must I really be fit? I getting it. You know, where here you see here it's p into brackets 9 greater than x less than 15. Right? This 9. Where x? The question didn't ask us to find x minus 1 and x2 is 15. The question didn't ask us to find x1 9 and x2 is 15. It says we should rather find between 9 and 15. We should find the x between 9 and 15. So here too, we said that now when we translate it from normal distribution to and we use the z-score, it is no more x. We are now into the what? Z domain. Are you getting it? So when we are in the z domain, the x1 in the z, it is called z1. So if x1 is 9, we have changed the x1 to z1, and the 9, we've changed it to -1. We have changed the x2 to z2, and the 15, which is for the x2, we've changed to 1. So we are no more solving for x1 and 9, x1, we are no more solving for 9, between 9 and 15 again, no. We are rather solving for between -1 and 1, because the -1, 9 is 15. Understand it? Do we understand it?
Yes,
Yeah.
please.
Yes.
Instead have a mature notation, probability into bracket what? -1, then 1. Between them is what? I'll not write an x, I'll write a z. Now use less than, because we are no more dealing with x. We control x, but waiting. We are using z. If it is an x, you better only say p into bracket what? 9. My mentor was saying x the end. X the end you say p into bracket what? 9. Then 15. X is in the middle. That's it. It is say yasesa z x na cause z negative 9 no yasesa no and I be negative 1. 15 yasesa na be 1. Do you get it?
Yes.
Good. So after this, so what I've just done is this one. Is this one. Is this one. This is for only one x value, z value. The one we are doing now is for 2z. So having finished with this, the whole stage 2 and that whole stage 3. What is stage 3? Draw the standard standard normal distribution. Natural standard normal distribution. When will you reopen school?
20-something
When you guys
September.
back here, when will you reopen school?
No,
okay,
it's
okay, then
October.
maybe when I come, you'll see me. Yeah, don't kill yourself here. Normal. Okay. Now divide it. To draw. A curve line is freehand, but a symmetrical line is the ruler to draw. You shouldn't. When students, the Omega said that's how he solved that diagram. Curve. He all mean no day is green or 0. It is standard normal, mean is 0. Here. So in the standard normal, the mean is 0. Then we have two z values. We are going to plot them on the curve. Negative 1 and 1. The negative 1, does it come before 0 or after 0? Before 0. So I'll come and mark it. When I mark it, let us touch the curve and the horizontal line anywhere. You have space because I'm going to shade. Then the other one. So this one is z1. The other z, which is the 1, does it come before the 0 or after the 0?
After the 0.
You mark it anywhere. You write 1 here. You write a z2. And the question says we should find between. We should find between this. This is what the question says we should find. Here in the standard norm, after the z-score, we don't make use of the x again. If you bring the x, we are trying to say the x is the same as. That's what we are going to say. But I'm not going to write anything x here in the standard normal. Everything here is for z. After the z-score, everything there is for z. When we bring the x, it's just to tell us that it's the same as this. It's the same as this, as I was explaining. So we're on the third stage. So here, it said we should shade between. We are going to find between negative 1 and 1. Just as here, it was between 9 and 15. Here, in the standard normal, the x1 has been converted to z1. And the 9 has been converted to negative 1. And the x2 has been converted to z2. And the 15 has been converted to 1. And the 0 and the 12 has been converted to what? 0. Why? Because in the z area, in the z domain, we are dealing with probabilities. We are dealing with probabilities. So the mean is always the 0, like a number line. Then we shade in between. So let me shade. I'm shading here. You shade. And I'm shading there. So my break 4 hours, my child there for free. Hey. You don't go and pass. Let me see. Me in future, I come and send me a message. Say, no, I have a receipt to. Hey. I'll first fire you before I'll even ask somebody to come and do. Okay, so this is it. So after this, where do we go to? Now, we go and work on the notation. So I'm going to write the notation. Remember, before I can find the notation, this is what I'm to find. P into bracket negative 1 is less than z is less than 1. Right? So before I can find this notation, I must first find them individually, just as we did here. I'm not to find z equals 1. But I'm to find z is less than 1. But before I can find z equals 1, is less than 1, let me go and find z equals 1, probability. Then I found it. Then I came to find the main thing. So just like here, let me first go and find pz equals negative 1. Let me first go and find that one. Right? So p, probability of what? P into bracket z equals negative 1. Then after I find it, that will be for this. I also come and find for z2. So this is z1. I also come and find for probability of what? Z2 is equal to what? 1. I also come and find for them. Are you good? Are you good? Are you good?
Yes.
So I'm finding the probability for the z equals -1, just like here. We had z to be equal to what? Z is equal to what? 1 here. Then I came down and found z equals 1. What is the probability? What is the area? What is the proportion? What is the percentage? That's it here. So the same thing. I found z equals -1. After the diagram, let me come and find probability of z equals -1. Probability of z2 equals what? 1. Are you good? Okay. Let's go to our table. So here, we are using half table still. So -1 is the same as what in the half table? -1 in the half table is the same as what?
1.
It's the same as 1. Because I said, look at this. If it's -1 here, and we fold it, on which number will it fall on the right side?
1.
It will fall on 1. So this 1.0 is the same as -1. So we having -1, but because we are moving it to the table, because we are moving it to the number distribution table has one number, a digit, and 2 decimal places. So all the time, if there's nothing, just change to 2 decimal places. So this 0.00, this 0.00. Okay, so 1.0, this is 00. Where do we meet it? We meet it here. So it will be 0.34134. 0.34134. Negative. I'll bring a negative here. Are you good? Are you good?
Yes.
Are we good? Yeah. But then you let me remove the
Yes.
negative. I'll explain why I'm removing the negative. Let me remove the negative. I'll explain why I'll remove the negative. Because look at this. If it's a negative, even if it's a negative z, do we have a negative probability in any of them? No. Do you get it?
Yes.
Though it's negatives, there are negatives here, the full table. Do we have the probabilities being negative? No, they are still positive. So if it is -1 and it is the same as 1, the area is still the same. It will not be negative. It will still be positive. Are you getting it? Because the total area under the curve is 1. It didn't say we have -1. So though it's still negative, it is still 0.341334. Now let's go to Z2. It's also 1. So it will also be the same what? 0.3413. Are you good?
Yes.
Hey, am I teaching only one person?
No.
Okay, so now I found the probability for the individual figures, this one and that one. The question asked me to find for any of these things. Did the question ask me to find? What is the question asking me to find eventually? What is the question asking me to find?
Between -1 and 1.
Yeah, the question I should find between 9 and 15, which is the x. But this one will not give me the answer. I have to rather use the between -1 and 1. This is what will give me the answer. So I just found for PZ equals 1, PZ equals 1.0. But the question didn't ask me to find for this. The question said I should find P between -9 and 15, which I've changed it to be between -1 and 1, Z. So I'll come and write the Z here. P into bracket -1, then 1, then Z in the middle, then less than. Now watch. So to find P -1 Z and less than 1, it is just the same as saying that what is the distance between 0 and 1? And what is the distance between 0 and -1? Because I said it is Z is greater than -1. So this Z here, it is greater than -1, but it's less than 1. That is why we have shaded it. So it means that for me to find the between -1 and 1, I have to first find for PZ1 equals -1, which is this. Then PZ2 equals 1, which is this. Because this PZ1 equals -1, which is 0 to -1, the distance from 0 to -1, the whole area, this is it. And the PZ2 equals 1, 0. It means from 0 to 1, the distance, the area there, this is it. So between -1 and 1, it is equal to P into bracket Z equals -1.00 plus P into bracket what? Z2 equals what? 1.00 area. Then what is the area for P into bracket Z1 equals -1.0? 0.34113, right? Then plus 0.3413. Do we get it?
Yes.
Do we get it?
Yes, please.
One call price before we show. Hey, 341, 34134. 34134. Okay, they brought a 4 here. One call price before we show. Hey, don't go and spend time because TikTok. You and Marco. Hey, go and sit down and practice it. Once a Dawson, my talking about a break. So go and sit down and go and revise it. Go and play the video and revise it quickly. 9 couch him. And yes, I'll be fee. Yo. Like, can I say, oh, he has studied that. I've understood mathematics. We don't speak for it to stick. You have to practice it. So if you don't go and practice, you really be feared. Two of them say, or if I know now we. So 0.68268. Is that correct? Is that correct? 0.68268. Is that correct?
Yes, it is correct.
That's correct. So this is the probability between let me see whether I will explain the B or we should solve it. So I'm done. I'm done with the A. Don't wait till last minute too. As if when you finish writing it, you don't meet this thing. You meet it again. You are going to meet them again. This regression and you are going to meet them again. Some people you don't even believe. And I've told you, I've taught so many students, so many. And I showed it to you at the beginning of the session. I've taught so many students. I getting it. So many students. Some are even doing. The girl who spoke to me, who was speaking to me, she's doing a master's. I started teaching her from level 100. Level 100. Samantha. It's from level 100. She's doing a master's. Some are even finished. Like so many people. So when I'm teaching and I say go and practice now with Diagra, it's up to you. I getting it. And I don't have so much time, so I'm dedicating my time to help you. So let's look at the B. B here. Xavier, the gentleman who is also a co-admin in the group. The second one, the second person is an admin. He works at UNB, head office. We all like teaching, so we come to campus to go and teach. He's a graduate. He's also pursuing his master's. He works at UNB, but we like to come and teach, so we come and teach. He works at UNB head office. He's a banker by a party trade. So he says that's coming to campus to come and teach. So when you schedule the class and you are like, I'm waiting till exam time, master. Sometimes you know how much we charge when he says that I want to come and teach students. Last semester, the master students, when I organized that, they were not joining. When it was getting to exam time, they were joining the class. I was charging each of them 50 cedis per session. They were like, hey, Sema, no, your fee is expensive. I said, master, I don't have time. I stopped teaching them. They are like the undergrad. They're also relying on tutorial questions. Cedis per session. They were like, some people are taking 20. I said, some people are taking 20. What is my business with that? I'm taking 50 if you don't join. And only three will join. Only 4. Then I stopped teaching them. I told them this semester, if they want to come and teach, they should make sure they will pay me well. When I give the price, they should reduce it small. Otherwise, I'll not have time for them. So So Xavier, when you organize it, don't wait till last minute. You see, only one person no. We just finish with the B because I need to explain. All right, that's fine. Let's look at the B, whether I'll solve a bigger question on the B. If I'll not solve any bigger question on the B, then guys, I'll let you to go and solve the B yourself. Based on the understanding of A, you should be able to solve the B. So let me see how the sketch will be quickly. So more than 18 minutes. 18 is this unit B. So unit B is 15 here. Then 18 is here. So what will be the more than? I have to solve this. Gosh. Oh, okay, let's do it. I thought it was similar to this. I would have skipped it. But more than 80 minutes, the region will be here. So let me cancel it and let me go and solve it. Are you guys following? Hi. The doors one. Are you following?
Yes,
Yes,
please.
Yes, sir.
Okay, let me come here. So I'm done with this. I'm here. See. Pay attention. I'm moving very quickly. So I'll be asking you for the steps. Then you just tell me what it is. So more than 18, let me write here unit B. What do I do next? When I write unit B, look at the unit here and tell me what I'll do next. Don't say anything which I have not written. If you say anything which I have not written, I'll head you. So I've written unit B. What do I do? What do I do next? Where is it? I've written unit B. What do I do next?
You draw the normal distribution diagram.
I know you. I'll head you, Shadrach. I'll remove your balls. I'll remove the testicles in your testes. I'll remove the testicles in the testes.
You know it.
On the board, after unit A, what did I write next?
You stated the mean and the standard deviation.
I said just follow the steps. It's the same thing I'm going to use for the next one. But just that there are some few variations. You see, after I told him I removed the testicles from his testes, now he's now serious. He's giving the right answer. Unit A. So mean is what? 12 minutes, right? I'm tired.
Yes. The mean is 15.
So yeah, the mean,
15,
let's go. It's not 12. It's not 12.
It's 15.
So unit B, what is the mean? 15 minutes.
15.
So unit B,
yes.
the mean is what? 15 minutes.
15.
And the standard deviation is what?
2 minutes.
2 minutes. So the standard deviation, you want to write a symbol, you write it like this. On the right, then this way. That's it. Because I'm able to start writing things I don't even know. So after all, what do we do next?
You
write the
notation.
Notation for the first one. So B, more than 18 minutes. More than 18 minutes. I should have had a different session for this one. More than 18 minutes. I'd like to make it very long. So more than 18 minutes. So probability I. Probability into bracket what? More than 18 minutes. The proper notation is what? P. They said something is more than 18 minutes. Something. What is the something? What do we replace with the something?
X.
X. It's more than 18 minutes. So something they can say more than here. Some of the question could say more than, right? Some of the question could say more than. It could say greater than. It could say above. It could say beyond. It could say higher than. So more than, greater than, above, higher than, beyond, on to the right of 18 minutes. They can use all those phrases and words in place of more than. So you have to take note of that. 18 minutes. So more than 18 minutes. So first, I have to know that X is equal to what? The first one of the X is equal to what? 18. So after I got this, what is the next thing to do? After I drew the X. So here, I'm here. After this, I'll write normal distribution diagram and I'll draw the diagram. Normal distribution. If you guys will pay my transportation, I'll come and teach you. I'll not charge you much. If you not pay, I will not come. Economics, I don't think, I'll see. So here, right? We are doing the normal first. So the mean will be in the middle. What's the mean? 15 minutes.
15.
Then X is what? 18.
18.
Is 18 before 15 or after 15?
After.
After, so 18 will be here. Then the question says, what is the question asking us to find? More than 18 minutes. That is greater than 18. So this arrow, which direction is it pointing on the 18? Is it to the left or to the right?
To the right.
To the right.
To the right. So I'll shade the right region here. This is where I'll shade. This is 18. So to the right, I'll shade this part. That's why I'm going to solve it. Otherwise, I wouldn't have solved it. So I'm solving here. This is what they said I should solve. So I've gotten the normal distribution diagram. What is the next step to follow?
You look for the z-score.
The z-score. That's the stage 2. So I finished the stage 1. I'm done with. Let me go to stage 2. Z-score. Z-score equals X, random variable X, mean and the standard deviation. So what is the random variable? X is what? 18. What is the mean? 15. What's the standard deviation? 2. What do we have? 1.5, right?
Yes, please.
Okay, so 1.5. So
Network. Network.
side 1.5, right? So that's it there. 18 minus 15 over 2 is 1.5.
Yeah.
Then we have, okay, so Z is equal to what? 1.5. Then the question asks us to find the Z.
No.
The question asks us to find Z equals 1.5.
No.
Hey, where are all of the students?
Yes, we are
Fina,
here.
why is Fina quiet? Where is Lisa? And where is Portia? And where is Daniel and Co? Frederick and Co? Okay, so Z equals what? 1.5, right? So the question asks us to
Yes.
find the Z equals 1.5. Is that what the question asks us to find?
No.
Hey, class, should we end the session?
No. No.
I'm recording, so if I end the session, I'm just left with, after this, I'll solve this one. I'll solve the D. The E, I don't know. It's theory, so I'll read it for you. Explain it to you, then you go and write it. It's quite a lot, but let me finish it. This person should wait for me. Okay, Z equals what? 1.5, right? The question didn't
Yes.
answer to find Z equals 1.5. Say we should find X is more than 18.
More than
And
18.
we've changed our X to Z. Our 18 is now what? 1.5, right? So we are rather to find
Yes.
E into bracket Z is more than what? 1.5,
Okay.
which is the same as P into bracket what? X is more than 8. Are we good? So after this,
Yes.
Yes.
after writing this, what do we do next? We draw our standard normal distribution diagram. We draw this diagram. I'm drawing things so. Okay, here. So in the standard, you have to write the name. So let me write SND, standard normal distribution diagram. Then write it. Then you underline it. So under this diagram, the mean is 0. 1.5, is it after 0 or before 0?
After.
After.
So after. So I'll shade here. So I'll come and shade here. I'll write here 1.5. And the question is to find above to the right. So I'll go and shade here. Are you getting it?
Yes.
Yes.
That's what I'll shade. So that's what this question says I should find above 1.5. So now, whilst I'm done, before I got the Z is greater than 1.5, I must first find Z equals 1.5 probability. So down here, probability is equal to what? Z equals what? 1.5. So to find Z equals 1.5, I'll use the half table and I'll go to the in normal distribution, there should be two decimal places. So 1.5 is the same as what? 1.50. So here, 1.50. This 5, and here we have 0, 0 here. So where do they meet? Both of them meet at this region. So what's the figure here? 0.4332. Do you understand it?
Yes.
Do you understand it?
Yes.
Yeah.
0.4332. But the question asks us to find Z equals 1.50. No. It said we should find P into bracket Z is more than 1.5. We are dealing with half table. So you look at this. What this Z equals 1.50 means is that from 0 to 1, the area from 0 here to 1 here, this side.
1.5.
From 0 to 1.5, yeah. From 0 to 1.5, this side here, it is 0.4332. Meanwhile, all the area on the right side of the symmetrical line, what is the total area on the right side of the symmetrical line?
0.5.
So if the whole area from, let me use black. If the whole area from the symmetrical line to the right is 0.5, meanwhile, from 0 to 1.5 is 0.4332, then what will be the area after the 1.5? How do we find it?
You subtract
the 0.4332 from
Good. So it will be
0.5.
0.4, no. It will be 0.5 minus 0.4332. That's it. Because from 0 to 1.5 is 0.43 to the area. But the whole area is 0.5. So what is the balance area left? Or what's the remaining area left? So what do we have? We're going to have 0.668. Are you good?
Yeah.
If the question says find the percentage, then after you find the probability, you multiply by 100%. That's the percentage. But here it says find the probability. So you end it here. That's it here. So this is the area.
Okay.
That's how you solve this one. Are you okay?
Yes, please.
Yeah.
So see, let me look at it. It said between 13 and 17. Let me see. So between 13 and 17, if I draw the diagram, it will be like the second one. You go and solve it. I want to save time. I'm really, really tired. From 5:30. They are not paying me shishi. Okay, let me do it for you. Here. This is 13. No, the mean here is 15. And this side is 13. And this side is 17. Someone should find the z-score for 13 for me. So the z-score 1 for 13 will be 13 minus 15 divided by 2. Someone should find the z-score for me. Then the z2 will be equal to 17 minus 15 divided by 2. Someone should find it for me. This is -2, -2 is -1. This
Yes.
is 1.
One.
So your Z, this is your normal distribution diagram. The standard normal will be this. 0 here, right? Then here, you have 1. Here you have what? -1. Like the second one, like this one. Are you getting it?
Yes.
Like this one. So you should be able to solve this one. Okay?
Yes.
So I will not solve the II. The II, I will not solve it. For the C, II is like the B, II. Just follow the method and you'll do it. Are you good?
Yes.
Yes, sir.
Okay, I'm done. So B, the II, do it yourself. So do it yourself. That's it. Let me go to the D. The D says, if Unit A handles 1,000 calls, Unit B handles 800 calls. Estimate the number from each unit expected to exceed 18 minutes. Expected to exceed 18 minutes. Hold on. Okay, so back to the... All that way, I didn't record it. So we are on the D. The D says that if Unit A handles 1,000 calls and Unit B handles 800 calls, estimate the number from each unit expected to exceed 18 minutes. To exceed 18 minutes means exceed is more than 18 minutes. More than 18. So the probability will be into bracket X something is more than 18. And this we are going to use to solve. This will be the notation for both Unit B, and for Unit A. This is what we're going to use for both Unit B and Unit A. So between the Unit B and Unit A, we've solved, this is more than 18 minutes, which is for the Unit B. So for the exceeding more than 18, we've already solved it using Unit B, right? From the question of the C, more than 18 minutes, that is P is bracket X is more than 18. So when we come to this question, we solved it here, more than 18. And we got this 0.0668. So for the D, the Unit A, if you want to solve the Unit A, or you have to solve the Unit A. But before you can solve the Unit A, you must first use this notation and find the probability, right? So the way I'm going to solve the Unit B, that's how you use it to solve the Unit A. But the fortunate thing is that for the Unit B, we saw the more than 18 for the Unit B already. So there's no need for me to go and start from the beginning to find the probability and all that. We saw for the Unit B, more than 18 minutes here, X equals 18, the diagram, and we got the Z equals 1.5, then we've gotten the 0.068. So I'm using the Unit B as I'm solving the Unit B because that one is easier. We've already solved for the 18. So it is P into bracket X is greater than 18, bracket close equals probability of the Z, which is 1.5, which is here. I'm just recopying what we did here, equals 0.068. So you see the arrow pointing from the 0.0668 to bottom. And we have to find the number of calls exceeding 18 minutes. And this 0.0068 is the proportion or percentage or the probability of exceeding 18 minutes. So I multiply the 0.0668 by 800 calls, because in the question it says we should find for 800 calls for the B, 800 calls. So it gives me 53.44 calls, which is approximately 53 calls. So for the A, you also have to go and find the P into bracket X more than 18, which will give us something like this for the graph. Then for the A, the mean is 12. 18 will be on the right because it's more than 12. And we have to find more than 18. So you shade the more than 18 here. So just as we did for the B, you do the same for the A. When you eventually get your area or the probability figure, you multiply by 1,000 calls. That'll give you for the D. So you have to go and solve the A by yourself. Now let's look at the E. The capital promise that calls will be completed within 18 months. Identify the units more likely to meet the promise and justify your answer statistically. So let me look at the question. So the person says that we should find, let me see it carefully. Normal distribution is, you have to think very well. It says the company promises that calls will be completed within 18 minutes. Identify the units more likely to meet the promise and justify your answer statistically. So identify the units. You have two units. What are they? Unit A and what? Unit B. And how going to complete within 18 minutes. In other words, it's going to be X equals 18. Let's say it's going to be X equals 18. Exactly. Are you getting it?
Yes.
If it's X equals 18, and I have here, hold on, and I have here to be 1.5. 1.5 will give me this plus 5. This is 0.93. Okay, so watch. So within 18 minutes means that it should not be more than 18 minutes. So it's going to be something like this. Are you getting it? Within, meaning they can start from 1, 2, 3, 4, 5, but it should not exceed 18 minutes. Are we getting it?
Yes.
Within 18 minutes. They didn't say exactly. If they said exactly 18, then it is X equals 18. Exactly 18, or it is 18 minutes. Or the company promised that the course will be completed at 18 minutes. Then it's going to be X equals 8. It said within. Within means they can complete within any minute, or they can complete from 1 minute to the 18th minute. It should not exceed. So it's going to be X, a certain value here will be less than or equal to what? 18. So the most value should be 18 minutes. No one should exceed 18 minutes. So we use the less than or equal to, which depicts what is called the maximum. The maximum number of minutes should be what? 18. It shouldn't be lower than 18. Be more than 18. Are you getting it?
Yes.
Yes.
That's what makes sometimes normal distribution difficult. This within, less than, more than, exceeding, those are the things you have to take note of. Are you getting it? So it's for the each unit. So you have to solve it for the A and B. Then we'll advise which one is better. Are you getting it? We'll advise
Yes.
which one is better, which one is showing more, which one is better. So, less than 18. Okay, let me solve only, I'll solve only the A. I'll only solve the A. Then you guys will go and solve the B. Are you getting it?
Yes.
Are you getting it?
Yes.
I'm solving. It says the company promised that course will be completed within 18 minutes. Within 18 minutes means from 1 minute to 18 minutes. So it's less than or equal to the highest or maximum should be 18, not less, not more than 18. And said identify the units more likely to meet the promise. Are you getting it? And justify your answer statistically. So you have to solve for unit A using X is less than or equal to 18 notation. Right? Then we use unit B. X is less than or equal to the 18 also notation. That's what we have to use. Are we okay? So we will do this for
Yes.
unit A. Then we will go and find the probability. Then we'll go and do the same for unit B. Then find the probability. Then when we finish, we will compare. Are you getting it? So when we compare the one which is we finish, the one which has the higher value, that is what will be more likely to get the answer. Are we good? Are we good?
Yes.
Okay, so let's go on. So we are going to, do you have exams tomorrow? Do you guys have exams tomorrow?
No.
No, please.
Okay. So you have the whole day tomorrow. You can be watching the videos and practicing. If you know somebody who will disturb you on campus,
Or online class.
if you know someone who will disturb you on campus, don't go and sit there and this one is no time for friends. So you get reset. You are the only person. You have to score an A. So let's go. Unit A. Let's go unit A. I'm solving it very quickly. So we are solving for P into bracket X into bracket within 18 minutes. That's what we are solving for, within 18 minutes equals what? P into bracket X is less than or equal to what? 18. Okay, so let's see. X is equal to less than or equal to 18. So we'll come here and we'll say that X equals 18 first. We'll say normal distribution diagram. Normal distribution diagram. This is with the unit A, the mean is 12. The standard deviation is what? 3. So it is 12 here. 18 is above. And it said below it's with 18 inclusive. Okay. So I'm done with this. So I'm going to have here to be the z-score is equal to random variable x, the mean over the standard deviation. The x is 18 minus the 12 all over 3, which will give us what? 5 over 3 will give us what? 1.1. Is it 1.4? Do it for me. 5. Okay, let me use my calculator. 5 over 3 is what? 1.67. Are you following?
Say 6 over 3.
Oh, 6 over 3, so it's 2. Okay.
Yes.
6 over 3. Thanks. It's 2. So it is 2 here. So my z is equal to what? 2. So if my z is equal to 2, I'm rather to find probability of z is less than or equal to 2. So I'll come and find my standard normal distribution diagram. And I'll draw it. Then my mean is 0. And my this is 2. And I'm to find below this. Okay. That's it. 2. Not less than or equal to. So I come here and I say I first find P into bracket Z is equal to 2. Then I come and find P into bracket Z is less than or equal to 2. Less than or equal to 2. So let me go and find P, Z equals 2 from the table. I believe you guys understand it. I'm moving very quickly because of the time. So this is 2, 0. I have 0.4725. Have you all seen it?
Yes.
0.47725. 0.4772. So I have here to be 0.47725. That I have less than 2. So it should be 0.47725 plus 0.5. I hope you guys understand it. Do you understand it?
Yes.
0.97725. Go and practice. Okay, so this is the probability, 0.97725. So I solve for the A. I solve for the unit A. That's it. So now I'm going to solve for unit B. Unit B. Unit B has a mean of 15, standard deviation of 2. Then I'm to find P into brackets within 18 minutes, which is the same as P into brackets X less than or equal to 18. So let me plot X equals 18. Normal distribution diagram. This is 15. Then 18 is more than it, below 18. So they use the z-score, the second stage. Random variable, mean, and the standard deviation. Then X is 18 minus the mean, 15, all over 2, which will give me 3 over 2, which is 1.5. Then I'll come to z is equal to my 1.5. But I'm to find the probability of z less than or equal to 1.5. Okay. Then I'll draw my standard normal distribution diagram. 0, and 1.5 is on the right. And I'm finding below 1.5. Shaded region. Below, that's what I'm to find. So let me first find P into bracket Z is equal to 1.5. That is the distance between 0 to 1.5 on the normal distribution diagram. So Z is 1.5. If Z is 1.5, that's 1.5. Z is 0.43319. So 0.43319. Then P into bracket Z equals, I'm to find, what am I to find? I'm to find P into bracket Z is less than or equal to what? 1.5, which will be equal to the 0.43319, which is the distance from 0 to 1.5 plus 0.5. Are you good?
Yes.
Which will give us 0.93319. So if you don't know which one is greater, just multiply them by 100% so I can see the percentages. It will tell you which one is greater. This will give us what? 97.725%, right?
Yes.
This one will be times 100. This will give us what? 93.319 what? Percent. So let's look at the question. The question says, hey, you people, you've taken a lot of my time. Anyway, I'm done. The company promises that calls will be completed within 80 minutes. Identify the unit more likely to meet the promise and justify your answer statistically. So justify your answer statistically means show working. Are you getting it? Show working.
Yes.
So I've showed working. So between the unit B, whose figure is this? Whose figure is this? And the unit A, whose figure is this? Which one of them is more likely to be able to make calls within 80 minutes?
Unit A.
Choose the one with the higher. So
Unit A.
Unit A was 97.7 something percent. Unit B was 93.319%. So 97.725%. So between these two, which one do you think we're able to make complete calls within 18 minutes? Choose the one with the higher percentage.
Unit A.
So it's unit A. And you write it statistically, unit A will be able to complete the course within 18 minutes because it has the higher percentage of being successful at what? 97.725%. It means the percentage, the percentage it has to be able to achieve the 18% is 97. Meanwhile, unit B's percentage or probability of achieving it is what? 93.31%. So unit A would more be able to achieve it than unit B. Are we good?
Yes.
So you see, I can really speed up when I'm solving calculation. Only that when I'm explaining, I have to take my time and explain. So guys, I'm going to upload it. Today we saw probability and normal distribution. Go back tomorrow and sit down and all the questions I've solved. Today I solved question 5, question 10, and I said, and question 7. This is question 6. And I said that question 10 is like question 4. Question 4. And I solved only the last part of it. So take time tomorrow and study and practice, watch the videos and practice because it's coming to the exams. They will bring one or they can bring about 3 or 4. You don't know which one. And the objectives, the MCQ, solve them on your own. I don't know how you do them, but just if anyone has solved it or has gotten the solution for the objectives, 1 to something, how many are they? 1 to 60. If anyone has gotten the solutions for 1 to 60, share it with me. I'll share it in the group so your friends will look at it. But for question 1 and the others, we solved them. Shadrach, you have the questions. You have the solutions.
Please for the objectives.
Yeah.
No, I raised my hand to ask a question to draw your attention.
So I've solved question 1. I've solved question 2. I've solved question 3. I solved question 4. I solved question 5. I've solved question 6. I've solved question 8. I've solved question 10. I'm left with questions 7 and 9. If I check if they are similar, I'll ask you to go and complete them. Let me check question 7. No, I have to solve question 7. Let me check question 8. I've solved question 8. Let me check question 9. How to solve question 9. Question 9 is regression. So I have to solve them with you. So I've solved all these with you. What's my idea, pa?
That's
Yes.
fine.
What the mum bomb was coming on bomb was saying, I know why I did what I mean, sure. I was saying, I mean, sure. Okay, so that's it. 1, 2, 3, 4, 5, 6, 8, and 10. I finished it. I'm not doing this. Tomorrow I'll finish it, then we'll be done. What's your question?
Please, when we're solving the A, we left the second question. It was 2 questions. They said identify the more consistent units. We left that one.
Which one?
The A.
Which one is it? Is it the one that's question 7?
The A. Yes. No,
The
question 6. Question 6.
Yes. Okay, and identify the more consistent units. Okay. Which is question 6, right?
Yes.
Okay.
6A.
Okay, so let's look at the solution. Question 6A. Very fun. Okay, this is 13.3. This is it. So we'll go with the B. The B has a lower coefficient of variation. So that shows more consistency, meaning that the likelihood of it changing is very low. Let me put it that way. Let me simply put it that way. So between the A and B, the A can change immediately, but the B will be quite slower to change. Are you getting it? Coefficient of variation.
Yes,
variation means changeability. Hold on, let me see whether I'm recording it. I'm recording it. So variation, when you say something varies, it changes. So what is the coefficient of variation? Here, like what is the magnitude of variation? So the CV can change very quickly. It will not show consistency. So we'll calculate the coefficient of variation for each unit and identify the more consistent units, the one which can remain steady for some time. The A can change very quickly by 25%, but the B will take some time. The B will be very slow to change. Let me put it that way. Are you getting it? So between the unit B shows,
Yes,
unit B shows, or unit B is more consistent because it has a lower coefficient of variation. In other words, because the B's change, if the B wants to change, it will take quite some time before it can change. But compared to the A, or compared to the B, the A changes quicker than the B. Are you getting it? Because the A has a higher coefficient of variation, but the B doesn't have.
Yes.
It has a lower. So the B is quite consistent. If it's going to change, it will take some time, a long time before it will change because the percentage is very small. The magnitude of change is very small. But the A's magnitude of change is greater than the B. So the A will be more prone to change quickly, more quickly than the B would. I get it. So you can write that unit B is more consistent because its CV of 13.33% is lower than the CV of unit A. The CV of unit A, which is what? 25%. So unit B is more consistent because its CV of 13.33% is higher than the CV of unit A, which is what? 25%. Are you good?
Yes.
Yes, please.
So when you are watching back the video and I said something, you didn't get it right, you can push the video back so that you can listen to what I said again or how I solve it again, and you solve it. That's one of the importance of, the video, so that you can play it backwards. And but for now, where we are doing the live session, if I go forward, you want me to come back, it's really difficult. But the video, when you listen to it and you didn't get it right, you can just go back again, capture it, go back. You can take your time so that you can understand it and pass it out. Are you okay?
Yes, please.
Yes, please.
All right. So we are done. Have a good night.
Okay. Thank you very much.
Yes, sir. Thank you.
Right. Bye.